All right, guys, sorry about that. All right, so this is advanced revision, and as it says, it's revision. So I'm not teaching from scratch, basically. So we are going in the assumption that you already know some stuff, and this is just a revision session, right? Now, I was haggling with the idea in terms of an approach, how to approach the revision. Do I do question by question, or do I do topic by topic? And the difficulty with doing question by question is that, for example, a question can have 5 different topics in it. Like for example, question 1 can have 5 different topics in it, all right? And I didn't want to be all over the place. So what it means is that we're going to be skipping from paper to paper. We're going to be doing topic by topic, right? But what I have on the screen is something that I just want to share at the get-go. It's something that I basically give to my class. I call it a must-know sheet. Can anybody hear me? Just making sure. Can anybody hear me and see the screen?
Yes, sir.
Yes, okay. All right. So this document is what I call a must-know study list, a list of items that, you know, if you know everything on this list of items, then, you know, you'll have a very easy time in the exam, all right? So I'm going to set it here and you can screenshot it so you can have it to look at later. This is just the first page, page 1, all right? It basically comprises all items or majority of the items that you need to know. This is page 2, items that you need to know. And you see functions on it, but function is no longer on the syllabus. So this was set up when functions was a part of the syllabus. So function is no longer a part of the syllabus. All right. This is page 3, which has the AP, the GP, summation. Right. Then we have some trigonometry in there, stuff that you must know. If you know these things, then the exam will be very easy. All right. These questions are centered around your knowledge of these things. And this is another page. So more trigonometry here. And then there's also some vectors there. All right. And then starts differentiation down at the bottom. Some stuff that you should know. Next page, differentiation continues. The next page, and it goes into integration. Right. And then over here on the last page are 2 graphs in particular that you need to know. So this one you don't need because this is advanced. You don't need this one. And you also don't need this one. But this one kind of, you know, because it's really long. But forget about this one for now. But definitely you need to know this one and that one. The graph of sin x and the graph of cos x. You need to know those 2. All right. This is a sin x graph again, but this is a modulus of sin x, but you don't need to know this one because modulus is not on your syllabus. So this one was just basically illustrating how we get the modulus function. All right. So these are some stuff that if you know these things, then you'll have an easy time in the exam room. All right. So we're going to do this thing topic by topic. And we're going to start with the very first topic that most teachers and most advanced programs will start with, and that's polynomials, factor theorem, remainder theorem, and so on, right? The way I'm going to do it, I'm going to do all the past papers down to 2012, and I'm going to also include the specimen paper, all right? And that's the approach we're going to use. I'm going to skip from paper to paper, and we're doing all the past papers, all the polynomials in all the past papers down to 2012. And then when we go to the next topic, which is going to be quadratics, we do the same thing. Specimen paper, 2022, 2021, 2019. Remember, there's no exam in 2020, all the way down to 2012. All right? So let's go. So the first paper, they bring up specimen paper. this paper for the exam syllabus that you're doing. So we're going to start. And as I said, I'm just going to be working. Maybe you can chime in these things. All right, so this question says, this first question says, determine the remainder when this expression is divided by x plus 1. When it's divided by x plus 1. Now, the remainder, when you divide x minus a, you divide a polynomial by x, is f of a, 1. And in that case, your a is negative 1, right? If you want to relate it to this theory, that's the factor remainder theory, that's remainder theory. And so that remainder r from this divisor is going to be equal to f of negative 1. And so basically substituting negative 1 in the function here. And so it becomes 2 times negative 1 cubed plus b times negative 1 squared plus 2 times negative 1 plus 5. So you see, the b is going to be a part of your answer. And you just have to leave it there. So this here works out to be negative 2 because the negative 1 squared is negative 1. So that's negative 2. This negative 1 squared becomes a positive 1 times b. So we end up with a plus b. Then this 2 times negative 1 is negative 2. And then we're adding back the 5. So this negative 2 and this negative 2, that's negative 4. Negative 4 plus 1 plus 5 is 1. So this works out to be b plus 1. That is our remainder. That's the answer there. Everybody go to that?
Yes, sir.
Yes, sir.
Good. It says if the remainder when the same f of x is divided by x minus 2 is equal to the remainder in a1 above, in other words, equal to this same remainder, they want us to find the value of b. So what they are basically saying is that the remainder from this divisor is the same as the remainder from this divisor. But the remainder from this divisor will be f of 2. That's the remainder from this divisor, f of 2. So essentially, what the statement is saying, we can say, i.e., f of 2, which is the remainder from this divisor, is equal to f of negative 1, which we already worked out to be b plus 1. So we're going to put that equal to b plus 1. So we just need to now calculate what f of 2 is by substituting the 2 again in the f function here for the x, and we end up with an equation that we can calculate the b. And so it's going to be 2 times 2 cubed plus b times 2 squared plus 2 times 2 plus 5. This will give us f of 2. It is equal to b plus 1. And then we just need to work out the values. So this 2 cubed is 8. A2 is 16. So this expression is coming out to be 16. This 2 squared is 4. And that's a b. So that becomes a 4b. Then this is 4. And this 5 makes 9. So we can just put this together and put 9. And that is equal to b plus 1. All right, I'm going to transpose now. Take this b over here and subtract from that 4b. I'm going to get 3b equals this 16 and this 9, that's 25. 25 goes on this side and become negative 25 from the 1 to give me negative 24. So I'm going to get negative 24. Then when I divide both sides by 3, I get negative 8. And so the b is equal to negative 8. And that is my answer. Want to go with that?
Yes, sir. Yes, sir.
All right, beautiful. Let's continue. All right, so this is not a polynomial. This is actually a discriminant question. So we're going to jump now and go to 2022. So we're doing it one topic at a time, all right? So I'm going to go to 2022 now. So we're doing a 2022 paper, which is right here. 2022. All right, so let's scroll up to question 1. A polynomial is always in question 1. And see if there's a polynomial there. Which there is. Well, this is a sum and product of roots. So we're not going to classify this as a polynomial. So let's search down. It's a sum and product of roots. The sum of roots again. was an expression for the equation from the projective. So that's not a polynomial. Let's say there's one in section question 2. Sometimes it is in question 2. So you're not going to get every topic on every paper. All right, here's a polynomial on this paper. It's in question 2. So you do between question 1 and 2. All right, or you know it's in section 1. All right, this says when the polynomial, this polynomial is divided by x plus 1 and x minus 2, almost like the same question, eh? Same x plus 1 and x minus 2. The remainder is 64. It's the same remainder, 64. That's what the basically is saying. The remainder is the same and is equal to 64. When the polynomial, this polynomial is divided by this, remainder is 64. And when it's divided by this, remainder again is 64. So essentially, what they are saying is that the x plus 1 divisor lead to a remainder which is equal to 64. And this means the remainder from this divisor is f of negative 1. So what that really means is that f of negative 1 is equal to 64. So you see the equation has two unknowns in it now. The equation has two unknowns, and so we need two equations to solve simultaneously to find out the b, the c, and the d. This divisor gives the same remainder. So what the basically is saying is that x minus 2 gives that same remainder of 64. So this essentially means that f of 2, because that is the remainder we divide by x minus 2, is equal to 64. And so we're going to get an equation from this and an equation from this. From this one, we're going to substitute the negative 1 here, here, and there. And we can just place the values in there. We can just place the values in there. Let's look at the space that we have to work. I do have a lot of space to work. So I'm going to establish the equations in a different color over here. I don't have a lot of space. I'm going to establish the equation right here and there, right? So the first equation is negative 1 in this. Negative 1 in this becomes negative 1 times 2 is negative 2. Negative 1 in this becomes a positive 1 times this negative 3 gives me negative 3. Negative 1 right here becomes negative c times negative 1 gives me a positive c. Plus this d plus c plus the d, and that is equal to 64. And this becomes negative 5 transpose and add to the 64 over there to give me 69. So I get an equation that is c plus d equals 69. That's equation 1. That's my first equation. All right. The second one I'm going to get from this. Let's do it here. It is now substituting the 2 in here, in there, and in there. All right. So the 2 in here is 2 cubed. 2 cubed is 8. 8 2 is 16. So this becomes 16. Then the 2 in here is 2 squared. 2 squared is 4. Then 4 times negative 3 is negative 12. Then 2 in here becomes 2 times negative c. 2 times negative c is negative 2c. Plus back the d. And that also is 64. And so that's our second equation. Now this and this gives me 4. And the 4 transpose on that side to subtract from 64 and make it 60. So I end up with a second equation that is negative 2c plus d equals 60. So these are my two equations. Equation 1 and equation 2. And I'm solving them simultaneously. Now I can subtract to eliminate the d. Right? So I'm going to do equation 1 minus equation 2. So it's this c minus this negative 2c. Minus is a plus, so that becomes positive 3c. So I'm going to get positive 3c to start, 3c. Then d, let me erase this. Then it's going to be d minus d. D minus d. D is eliminated. So this is equal to 69 minus 60 becomes a 9. So it means that 3c is equal to 9. And I subtract the two equations. Divide 2 by 3, c equals 3. Then if c equals 3, when I substitute this 3 here for the c, I'm left with 3 plus D equals 69. Subtract the 3 from both sides. D equals 66. So D will be equal to 66. So I can say, and the D will be equal to 66. And those are my answers right there. What about with that?
Yes, sir.
Yes, sir.
All right. So those are just some simultaneous equations. And this is surds. And we're going to go and look for now the polynomials on 2021. Let's go. 2021. All right. Remember, this is just revision work, guys, to solidify these things. All right. This is just revision to solidify these topics. Let's search for polynomials on 2021. Polynomials in 2021. Factor remainder theorem in particular. All right. So one right here, first question. It says, determine the remainder when this expression is divided by x minus 1. All right, same thing again. One unknown in there. So it's going to be a part of the answer. All right, so when you divide by x minus 1, the remainder is going to be f of 1. F of 1. All right, so this one is pretty easy. This means that our remainder is going to be equal to 1 right here. Right here means that we get a 7. 1 right here means we are subtracting minus 3. So this is 7, and so it's a minus 3. So we're saying R is our remainder. So that's the answer right there. All right, that's just pretty straight. Start share again. Everybody back with me? Everybody back with me?
Sir. Yes, sir.
All right, you know the technology goes sometimes. You have no control over the technology. It's not perfect. All right, so here it says, if the remainder when f of x is now divided by x plus 3 is equal to the remainder determined A1 of us. So CSEC just can repeat the question all the time. The questions are basic. So once you do past papers, they're good enough. The questions are repeated just with different values. So this is similar to a question that we just did. They are saying that when you divide now by x plus 3, the remainder is the same as we got above here. Same thing. So when you divide by this x plus 3, the remainder is going to be f of minus 3. F of minus 3. All right. And so f of minus 3 is now equal to this x minus a minus 3. So that's what we're going to set up. The f of minus 3 is going to be equal to the same remainder as above, a minus 3. All right. And then what is f of minus 3? F of minus 3 is obtained by substituting negative 3 in here for the x, in there, and we can substitute and work it out. I usually have a very small amount of space to work it in. So you don't have to write too many lines, right? So when we plug negative 3 in here, negative 3 cubed is negative 27. Because the negative 3 cubed is negative 27. So it's become negative 27a. Negative 27a. When I put negative 3 here and square it, it becomes a positive 9. 9 times 7 is how much? 9 times 7 is how much?
63.
63. Thank you. And then we plug the negative 3 here, it becomes negative 7 times negative 3 becomes positive 21, plus 21. And then we have this negative 3 come back here, and it is equal to the a minus 3, equal to a minus 3. And then we're solving this for the a. So this a, this 27a, I'm going to take it on this side and add it to that a and get 28a over there. So that's 28a on the left, on the right side, 28a. This negative 3 cancels with that -3. So those two are eliminated. I can literally just cross them out. They eliminate each other. And so now I'm left with these. And that is 84. So those two add to 84. So I'm left with 84 on this side. And so to find A now, A is equal to 84 divided by 28, which works out to be what? That's 3 times, right? That's 3 times. And so that is my answer. A equals 3. Nice and easy. Basically, it's almost the same question. But good?
Yes, sir.
But is okay? All right. So we're going to 2019 now. 2019. 2019. More maths equals better maths every time. 2019. All right. So once you can do these on the past papers, you'll be able to do the one in the exam room because they are the same. All right. So this is a functions question. It's asking us for all the linear factors. So this can be viewed as a polynomial, you know, because what they want us to do now is factorize. So we can treat this as a polynomial, this. And I want us to get all the linear factors. So factorize. And it's pretty straightforward because there's no constant term in this. So x is the first common factor. You can see that. So firstly, f of x is going to be x into 2x squared plus 7x plus 3. And then this is just your normal quadratic. And you have prime coefficients at the end. So it becomes very easy to factorize. And you have prime coefficients. But the only factors of 2x squared are 2x and x. The only factors of 3 are 1 and 3. We have to place them the right way. You have to place them so that your far product and your near product add to the middle term. So I have to put the 3 here so that I get 6x and put the 1 here so I get 1x. And they add to the middle term of 7x. And everything is positive, so that makes it nice and easy. So those are your linear factors. Nice and easy. All right? Those are your linear factors for that. 3 marks for doing that. Then I say compute the roots of the function. I think they really want to put this equals 0. So if these are our factors, then the roots are obtained when you put it equals 0. All right? So to put it equals 0 down here, put the function equals 0 to get the roots. Then this factor is going to give me a root of 0, x equals 0. This factor, it's like I'm putting the factor equals 0 and solving for x. The x is going to be -half. X will be equal to -half. And this one, if I put it equals 0, find the root, I'm going to get x equals -3. X equals -3. So those are the 3 roots. The roots are the x values when the function is equal to 0, corresponding to points where the function intersects the x-axis. All right? So that finishes that. Does it feel like a polynomial? This is a function. Function is no longer on the syllabus. So let's see if there's a real polynomial anywhere here on this paper. Let's see. Might be in number 2. No, that's a quadratic, which we're going to do afterwards. All right. So that's not a polynomial in a series. All right. So that was the extent of the polynomial on this paper. So let's go to 2018. 2018. Let's go to 2018. All right, let's find a 2018 paper. It's supposed to be somewhere here, right here. 2018. We're searching for the polynomial on it. 2018. The aim is for us to do all the past paper questions between now and Tuesday. That's what we'd like to do. If it gets close, then we might just do the more recent ones. All right, and we know which ones we can skip out. This is a function that's no longer in the syllabus. It's a function. It's no longer in the syllabus. Let's go functions. This is a polynomial. This question is a polynomial. It says derive the polynomial of degree 3, meaning x cubed. Degree 3 means x cubed is the highest power, in which the roots are these. So these are the roots, meaning x equals 1, x equals 2, and x equals -4 are your roots. If you know your root, then you also then know your factors. It means that your polynomial, these roots, will have a factor from this root is x minus 1. Factor from this root is x minus 2. The factor from this root is x plus 4. But can appreciate that? But
Yes,
okay with that?
Yes, sir.
Good. And then it's a matter of expanding this out because they said they want it of degree 3, meaning they want it to be expanded. So what we're going to expand it is multiply these two first. We multiply these two, get x times x is x squared. Then the term in the middle is the product of the sum of the far product and the near product. The far product is negative 2x and the near product is negative 1x. So the middle term is the sum of these, negative 3x. We have to do the mathematics the easy way. Right? So remember, it's a far product and the near product gives you the middle term. All right, so that becomes negative 3x, and then the product of the negative 1 and the negative 2, that's a positive 2 right here. And then multiplying that by x plus 4. Then it's each of these terms multiplied by the x plus 4. Each of the terms in the bracket here multiplied by the x plus 4, or if you like, each of these two terms multiplied by the terms in the bracket there. All right, so let's go. X squared times x is x cubed. X squared times 4 is 4x squared. Minus 3x times x is minus 3x squared. Minus 3x times 4 is minus 12x. Then 2 times x is 2x. Then 2 times 4 is 8. Then you consolidate the like terms. Those two and those two are like terms. You consolidate them. So that's x cubed. This and this gives me positive x squared. This gives me negative 10x because it's 2 minus 12. That's negative 10, negative 10x plus 8. And that's my polynomial of degree 3 or of order 3. Finish. Are you good?
yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
All right, let's see if there's any other polynomial anywhere near here. That's a quadratic, which we're going to do as our next topic. We're going to do some quadratics, complete n square. That's a series. We're going to do a couple topics tonight, all right? That's a quadratic again, alpha and beta, sum and product of roots. 2018 done. Let's go to 2017. One topic at a time. 2017 next. Let's go. Let's do this. 2017 right here. So do all the past paper questions between now and the exam. You're safe in the exam room. Make sure you can do them. Make sure you understand them. You'll be safe in the exam room. All right, the polynomial on 2017 is right here. This question. All right. This one says, given that the remainder, when this thing is divided by x plus 1 is 6. And that when this is, oh, this is a factor. Okay, so the x minus 2 is a factor. So this gives a remainder of 6. But then this is a factor. Now, if it's a factor, it gives a remainder of 0. All right? So simply put, we're going to have two unknowns in it, a and b. And so we need two equations. This information is going to give us one equation. This is going to give us a second equation. So let's lay it out. This part of it means that f of minus 1 is equal to 6. This part of it means that f of 2 is equal to 0. That's what they have said essentially. All right, so let's write it out. So the first piece of information was that f of negative 1 gives a remainder of 6. The remainder f of negative 1 is 6. That's going to give us our first equation by substituting negative 1 here and there for the x. Let's write it out. So plug the negative 1 here and cube it, it becomes negative 1. Plug the negative 1 here on the square, becomes a positive 1. But this minus remains minus, and so we end up with a negative 1. And then when we place the negative 1 on the x right here and multiply with the negative a, we get a positive a. And then we're adding back the b, and that is equal to 6. These two gives me negative 2. Negative 2 comes across, add to the 6 to give me 8. So my equation becomes a plus b equals 8. You have to be careful with the negative signs in these numbers. All right? When we're doing these questions. Then we have that this is the factor. X minus 2 is a factor, which means that f of 2 is equal to 0. The remainder is 0. This is going to give us our second equation by substituting 2 in the function there, where the x is. So 2 cubed right here is 8. 8. 2 squared right there is 4. So I'm subtracting 4. Then I'm 8 times negative 2. Negative a is negative 2a right there. I'm adding back this b, and that result is 0. Consolidate again. I'm leaving these 2 on this side. This is a positive 4. When I take it on this side, it becomes a negative 4. So I'm going to leave 2a plus b equals negative 4. So this is my first equation. This is my second equation. I want to solve them. Clearly, I can eliminate the b if I subtract them. It makes sense to subtract the first one minus the second one. 1 minus 2 is a friendly way to do the subtraction right now. So I'm going to do equation 1 minus equation 2, and we have to be careful with those negative signs. So a minus 2a, minus a plus, that's a plus 2a gives me 3a. b minus b gone, that is equal to 8 minus a negative 4, minus a plus, becomes 8 plus 4 is 12. Then I divide by 3, so 8 is equal to 4. If a is equal to 4 and I substitute that 4 for the a right here, I'm going to be left with b equals 4, because 4 plus 4 is 8. So the b is also going to be equal to 4. So I can say, and b equals 4. And that is it. Those are my values for a and b. But good?
Yes, sir.
Yes, sir. Yes, sir.
Let's see if there's any other thing on polynomial. I doubt it. All right, that's it for this paper. That's 2017. 2016, let's go to 2016. We're doing all of them. More maths equals better maths. We're doing all of them. If there's one question you must get right on the exam paper, it's polynomials, because it's very easy. Super easy. Super easy. They don't set them like they used to in the past. They're not very straightforward. All right? No complication on the questions these days. Let's go. So we're looking for the polynomial on this paper. Let's see. That's a quadratic, it looks like. That's logs. That's this guy's quadratic equation. That's functions. That's functions. Let's see. Let's look again. Maybe there's none on this paper. No polynomials proper. Logs. That's a quadratic nature of roots. I want to sketch that curve. Continue this series. All right, so there's no polynomial in 2017, 2016. So let's go to 2015. Work our way down. 2015. 2015 is right here. I was doing some work here before, so some more things about this. So 2015. All right, so now I cannot work on the paper. So this is the old setup. So I have to work on the right. All right, so all the polynomial question here. But we still this thing drop off. Can you see me again? Cool.
Yes, sir.
All right, so polynomial question on here. All right, the polynomial question on here is just this one. Just that. It says, give me that x minus 2 is a factor of this. We have to factorize it completely. All right, so let me bring up something to write on over this side. Let's do something to write down over here. All right, so we can't work on the actual paper for the remainder of the question because they're from the old setup. All right. So so I want to divide this out. So if this x minus 2 is a factor, right, it means that this can be divided by x minus 2. There are multiple ways to do it. Some teachers teach this using a synthetic method, but I'm going to use a long division. All right, so I'm just going to divide it out because what you want to do is divide this down, because that's a factor you can divide through by it. You can divide it down, factorize it down. You're trying to factorize it down. That's what I want you to do. So you divide by the first factor, which is x minus 2. All right, so we're going to do the long division on it. We're going to just divide it, x minus 2 into 2x cubed minus 5x squared plus x plus 2. And let me explain something to you, show you something. If, for example, they gave you 2x cubed plus x plus 2, and they did not give you a square term, when you set up a division, you write x minus 2. Suppose this was a factor, the function. You would put 2x cubed plus 0x squared. Then you would put plus bracket x plus 2. That's why you want to divide it, because you want to have all the terms down here, right? Of all the degrees, cube, the square, the linear, and the constant, right? You want to ensure that you have all of them. So if they don't give you one, you put 0 times that one, all right? Because you have to put like terms under each other, all right? So I just wanted to make note of that. All right, so we're dividing this now. So it's the first value divided by the first value here. It's going to give me 2x squared. Then it's 2x squared times each of these. Just as how we do long division with numbers, right? So it becomes back the 2x cubed minus the 4x squared. That's this times this, minus 4x squared. And then I'm subtracting. All right, so it's really this minus makes it a plus. So this is really like 4x squared minus 5x squared. 4 minus 5 is negative 1. So it's a negative 1x squared. I don't need to put the 1. It's just a negative x squared. And then these now are subtracting nothing. So they come back as plus x plus 2. Then it becomes this divided by the x, which is negative 1. Or negative 1x, negative x. Then it's negative x times these, which is going to give us negative x squared plus 2x. Plus 2x. This time it becomes a plus 2x. And then again, you're subtracting all of this. So this becomes a negative, because this minus makes this a negative 2x. So it's negative 2x plus x. Negative 2x plus x. Something looks wrong. Let's continue. Something doesn't look right now. But it's negative, right? It's negative 2x plus x. That gives us a negative x. And then this 2 comes back unchanged. It's okay now, plus 2. Then it's this divided by this x gives me negative 1 minus 1. Then it's minus 1 times these. And so it becomes negative x plus 2. Okay, so it's good. When you subtract all of that, the remainder is 0. So the function is now the product of this divisor and this quotient. This is a quotient and this is a divisor. Right? So basically, we can literally factorize this right here where it is. Right? We can factorize that where it is and write the result. Let me shift this over. We can factorize that where it is and get the result. So this up here we factorize into factors of 2x squared can only be 2x and x. Factors of the 1 can only be 1 and 1. This says the signs in the bracket are different. This says you must give the greater product the negative sign. So the far product is 2x and near product is 1x. The power product is greater, you want it to become negative like the middle term. So I have to put the minus here and the plus there. So those are the factors. Those are the linear factors. And so this becomes the product of these three things. This, and that. Those are the factors. So I can write k of x is k of x. K of x. K of x becomes this first factor, which is x minus 2, multiplied by the other two factors, 2x plus 1 and x minus 1. And that is those are your factors. That's your answer right there. Factorized completely. All right, so that was a polynomial on 2015. But okay with that?
Yes, sir.
Yes, sir.
All right. 2014 next. After this, we're going to do quadratics. All right, we're going to do quadratics after this. So 2014, we're looking for 2014. Where is it? Right here. 2014. Another paper we'll have to write out on the screen. So let's clear this. All right, let's put a polynomial in this now. So here's an all right, so a polynomial right here. This is a polynomial. All right, it's a polynomial. All right, so that polynomial says, it says when the expression, this expression is divided by 2x minus 1, remainder is negative 3 over 5, negative 3.5. But to determine the value of a. All right, so when this is a divisor, the quick way to find the a is to put it equal 0 and solve for x. That's a quick way to solve for a. You really want to find f of a. So to find your a, you put the divisor 2x minus 1 equals 0, and when you solve for the x, it becomes a half. So it means that the a that you're using in the theorem will be a half. Another way to look at it is to say the theory says you must have a linear divisor in the form k into x minus a. And then you're working with f of a. So f of a is either a remainder, leaves a remainder, or is equal to 0. In the factor theorem, it becomes 0. In the remainder theorem, it becomes equal to the remainder. So if I have 2x minus 1, and I want to get my a, I need to generate an expression in the bracket like this. I would have to factorize with the 2. So if I factorize with the 2, factorize 2 out of this, I'm left with an x. Factorize 2 out of this, I'm left with a negative half. And so there is my a. That's another way to find the a. There is my a. X minus a. So my a is half. So again, I'm finding f of half. All right? But most teachers teach it a way where they would put the 2x minus 1 equals 0 and then solve x equals half, and therefore my a is half. All right? That's just a gimmick way to do it. All right? But no problem. If you use that method, no problem. All right? No problem if you use that method. All right. So what the statement is saying, is that 2x minus 1 leaves a remainder of negative 3.5. I'm not going to work with decimal. I'm going to write that as negative 7 over 2. Right? Don't work with decimals in these things, right? Don't work with decimals, we work with fractions. All right. So what does this mean? It means that the divisor from this is f of half. So it means that f of half is equal to negative 7 over 2. So this is the equation that we want to set up and solve. F of negative half. So I want to plug negative half in the function over here. Let's look at it. I'm going to plug negative half in the function here, here, and there. I'm working with half, so I don't have to show the working. We're doing f of negative half. So already know, negative half cubed becomes 1 over 8. 1 over 8 times 2 is 1 over 4. So this first expression becomes 1 over 4. Then not negative half, half. Then half squared right here becomes a quarter. So that's a quarter times a. That becomes a quarter times a. Then a half here times the 5 gives times the negative 5, give me negative 5 over 2. Negative 5 over 2, that's what this becomes. Then I have this negative 2 as part of my function, and that is equal to negative 7 over 2. So to simplify this, I can multiply it through by 4. If I multiply it through by 4 right now, all the fractions will be gone. I'm not saying that you have to be that way, but I don't want to see all those fractions all about the place. So I'm going to multiply it through by 4 just to simplify and get rid of all the fractions. So I'm working only with whole number values. So this divided by, multiplied by 4 is 1. This multiplied by 4 is 8. This multiplied by 4 is 10, because 4 into 2 is 2 times 2, 5 is 10, so that becomes a negative 10. This multiplied by 4 is negative 8. This multiplied by 4 is negative 14, because 2 into the 4 is 2 times 7 is 14, negative 14. So I have those whole number values working with now. I'm going to leave this here as my subject. This is negative 18. Negative 18 comes on this side, becomes a positive 18. 18 minus 14 is 4. This one goes over and subtract from the 4, so my A is equal to 3. A equals 3. Got to go to that?
Yes, sir.
Good.
Yes, sir. Yes, sir.
Question done. Next question, 2013. 2013. 2013. 2013. Where is it? 2013. Where are you? Where are you? 2013. Right here. All right. So 2013. All right. So let's look for the polynomial here now. Okay. Polynomial. So the polynomial is right here. This is a polynomial, part E. 5 marks for the polynomial, right? Let's look at it. It says, given this polynomial function, use the factor theorem to show that this is a factor. It's quite simple. If this is a factor, then f of negative 4 will be equal to 0. That's what we need to show. All right? So first I'm going to state it. I'm going to state it and then show it. If, for part 1, if x plus 4, sorry, is a factor of f of x, then f of negative 4 will be equal to 0. This is what I need to show. That's what I need to show. And then I just show it. So I said, now, f of negative 4, I'm going to work it out now. It's actually equal to, I'm plugging the negative 4 in this, here, here, and there. All right, let's write it out. It's negative 4 cubed minus negative 4 squared minus 14 times negative 4. And then we have a plus 24 at the end. All right, let's shift this over a bit. And we have plus 24. Plus 24. All right, and then this will be equal to 0. So put it all in the calculator. Somebody can check it for me, make sure. All right, if we're going step by step, this is negative 64, negative 64. Then this is 16, so that's negative 16. Then write this out for me now. Negative 14 times positive negative 4 give me a positive number. What is that? 76? 76?
56.
56.
56.
How much? 56. Thank you.
56.
And then I added 24. So this is 78. That is 78. But this is not 78, so it's not right. Something is wrong somewhere. What is wrong? Something is wrong somewhere. Let's look at it. 14. Let's show that it is a factor, negative 4. This is 64 in truth. Huh?
Everything correct.
Everything correct?
Yes, correct. Yeah.
This equals 0? Oh,
Yes,
this
sir.
equals 80. Oh, okay, right. That equals 0. Thank you very much. Shown. Very good. That question done. Oh, then I'm finished. I'm saying determine the linear factors. So to determine the linear factor, we're going to divide by that. Divide by the x plus 4 to simplify this term. Again, if you want to use a synthetic method, no problem. Just make sure you get it right. Okay? Whichever method you use, make sure you get it right. There are other ways to do it, as I can break these down into x plus 4 factors, but let's just do the long division, right? Because that's the one on the syllabus. So I'm going to go and say x plus 4 into x cubed minus x squared minus 14x plus 24. I'm going to divide it down. This divided by that is x squared. Then it's x squared times these becomes x cubed plus 4x squared minus you're subtracting everything. These two first terms are always eliminated. So this is like minus 4x squared. So it's minus 4x squared and minus x squared. That's minus 5x squared. Minus 5x squared. These not subtracting anything, so they come back as minus 14x plus 24. Then it's this one divided by this. So that becomes a minus 5x. It's minus 5x times these, minus 5x squared, then minus that is negative 20, negative 20x. Subtract. Then this minus makes it a plus. So it is 20x minus 14x, that's 6x. 6x plus 24. Then it's 6x divided by x, it gives me positive 6. Positive 6, let's write that better. Positive 6 times these will be 6x plus 24. When you subtract this, the remainder is 0 because it was a factor. And this up here factorizes easily. So what will be the factors of this? Up here, it will be x, and then this factors of 6 that add. This means that I'm adding the factors to get the 5. Factors of 6 that add the 5 is 2 and 3. Let's write this better. Right? So factors of, it says x and x. Factors of 6 that add to 5 is 2 and 3. Signs are the same in the brackets. Both of them are negative. Negative, negative. So my factors are this one, and that one. Those are my factors. All right. So I can write that f of x, therefore, is x plus 4, x minus 2, and x minus 3. Those are the factors. Then we come to 2012, which is the last one we're doing on polynomials. 2012.
I have a question.
Yes.
Sir, for I, when it says use the factor theorem to show the x plus 4 is a factor, you couldn't have divided it first to show that it's equal to 0?
Yeah, you could have done the long division and show that it equal to 0. But you see, because them say use the factor theorem, because it says use the factor theorem. See this line right here? And it says use the factor theorem right here.
Yes, sir.
Factor theorem is about factor theorem is about when x minus a the factor theorem is when a linear divisor k into x minus a is a factor of a polynomial function f of x. If this is a factor, then f of a will be equal to 0. So I think they want you to do this and show that f of a equals 0. That's what they want you to do. So they want you to put the a in there. They don't want the long division because it is a theorem they want. All right? All right. But
Yes,
good question. Good question. Good question. All right. Remember, the remainder theorem now is that when the polynomial is divided. So the remainder theorem is that when f of x is divided by a linear divisor in the form k into x minus a has to be a linear divisor. The factor theorem only works with linear divisors. Doesn't work with quadratic divisors or any other kind of divisors. Only linear divisors that can be placed in the form constant times x minus a, because you want to see what your a is, x minus a. So you're looking for the x minus a as a linear divisor. So when f of x is divided by a linear divisor in the form k into x minus a, where k is a constant, the remainder is f of a. That is the remainder theorem. The factor theorem is an extension of the remainder theorem, because in that case, if this is a factor, then the remainder becomes equal to 0. That's what happens in the factor theorem. So the factor theorem really is an extension of the remainder theorem. Just that your remainder is equal to 0 because your divisor is a factor. When the divisor is a factor, you will have no remainder. Right? That is that. All right, let's look at number paper 2012. 2012. All right, let's find some here. Looking for 12. If you see it, just shout and say, see it there? 12. See it there? 12. 2012. All right, 2012. I'm looking again for the polynomial question. See it right here, more of the same. So let's see, we've done all of them. So anyone that gets in the exam, you must crush it. It is 1 mark for it, you want the 1 mark. That's all the polynomial. It says, if x plus 2 is a factor, find the value of a. Same thing again. Since this is a factor, x plus 2 is a factor. X plus 2 is a factor. The factor theorem says f of minus 2. Why is it minus 2? Because the x plus 2 can be written in the form x minus negative 2. So that becomes your a in the theorem. That becomes your a. So that's how we know it's f of minus 2. So f of minus 2 is going to be equal to 0. All right? So we're just basically finding f of minus 2 and equate it to 0. So basically we're plugging minus 2 in this. And all you have to do now, plug in the minus 2 in this, is be careful with the negative sign. So the negative 2 here gonna give us negative 8. Negative 8 times 2 is negative 16. That's negative 16. Negative 2 here is gonna give us a positive 4. Positive 4 times this negative 3 is gonna give me a negative 12. The negative 2 right here is gonna give me negative 2 times this negative 4 is gonna give me a positive 8 right there. Then I have this plus a, and all of that works out to be 0. Now this right here is negative 28. Negative 28 plus 8 is negative 20. Negative 20 goes on that side, come up positive 20. So I'm saying a equals 20. Equals 20. Because all of this is negative 20, don't it? Good? And negative 20 plus 20 is 0. So a equals 20. Done. And that concludes our revision of polynomials, factor remainder theorem. We're going to jump to quadratics now. So to do the quadratics, we can work our way the opposite direction now. So we can start at this 2012 and then go to 2013, 2014 and work our way up. All right, so let's do that. So starting back at quadratics. So let's finish polynomials. We're going to do any quadratic question we see, including completing the square, maximum, minimum, sketching the graph of a quadratic function. We're talking about sum and product of roots, and we're talking about discriminant of the roots of a quadratic equation. Anything to do with quadratics, we're going to do it right here. Straightforward quadratics, not quadratic like this. This is this guy's quadratic equation. We're going to do this one where we're doing logs and indices. That one comes under the logs and indices topic, even though it's a quadratic. All right, it's this guy's quadratic or a hidden quadratic, our equation reducible to a quadratic equation. Anyway, let's search for the quadratics on this now. All right, so there it is up front. That's a quadratic. This one we're going to do, this one we'll do a topic of inequality. So we're focusing on this part right here, part A. All right, part A for the quadratics. So let's go. We are now on quadratics, guys. Everything in quadratics we're going to do. All right, so this question says, the quadratic equation, and it is already in the standard form because we have equal 0 there, remember? These are your roots. Calculate the value of alpha squared plus beta squared. That's a standard question. What we have to remember is that alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. That's one of your must-know items. All right? That's one of your must-know items. And so we need to find the alpha plus beta and the alpha beta. Alpha plus beta is the sum of the roots. Alpha beta is the product of the roots. Right? This can be done multiple ways. It's x squared minus 4x plus 6 equals 0. Well, plenty of people will say this has roots. Alpha and beta, that's what the question said. Well, plenty of people will say that the sum of the roots, which is alpha plus beta, is minus b over a, and they will calculate it as minus. The b is -4. Note it's -4 because the equation that we're using, or the theory that we're using, is with an equation of the form x squared, ax squared, I should say, plus bx plus c equals 0. So the plus b is -4. And this equation or this expression for the sum of the roots comes from our equation being in that standard form. So it's minus the b, but the b is a -4, so it's minus a -4 over the a, and the a is the coefficient of x squared. In this case is 1. That's a 4. And the product of the roots alpha beta, formula-wise, is c over a. C over a. In this case, the c is 6. And so that becomes 6 over 1 or 6. So basically just plug in these values now, the 4 and the 6 in this expression. All right, and we can literally just write it out that the alpha squared plus beta squared is alpha plus beta all squared minus 2 alpha beta. And so we're using these values. So it's 4 squared minus 2 times 6. That's what it is. 4 squared minus 2 times 6. That becomes 60 minus 12. And 60 minus 12 is a 4. That's a 4. That's the answer is 4. But let me show you something though. The same equation, without doing anything, we could pick up the sum and the product, you know. Watch this. If you consider this, x squared minus 4x plus 6 equals 0. Every quadratic equation can be written in the form x squared minus the sum of the roots times x plus the product of the roots equals 0. Every quadratic equation can be written in this format, you know, where this represents the sum of the roots and this represents the product of the roots. This is already in that form, so I could have looked at it and know that my sum is equal to 4 because that's a minus and that's a minus. And my product is 6 because this is a plus and this is a plus. So I did not have to use the formula minus b over a and c over a because this was set out for me already in a friendly way. So I could have looked at it and just write that my sum of the roots, alpha plus beta, this is the sum of the roots, alpha is equal to this 4 right here. And the alpha beta, the product is equal to this 6 right here. I could have just written them down like that for this question and then still drop those values inside here. Could have just done that. But I understand that.
Yes, sir.
But I go do that.
Yes, sir.
Good. So if I was in the exam, I would do it. I would do it this way. That's how I would do it. I wouldn't bother write out no c over a and no minus b over a. All right? I would just do it this way because the equation is already set out in that form, representing in the form of the sum and the product of the roots already. But that finishes that question. Right? That's a quadratic on this paper. There's no other quadratic there. All right? No other quadratic. All right, so let's go and do 2013. Let's go into 2013 now. So working back our way up, 2013, which is right here. So looking for the quadratics on 2013 now. Quadratics on 2013. This is number 1, yeah. Looking for quadratics. Now see quadratics right here. All of this is quadratics. This is quadratics right here. Bang. All of this is quadratics. All right. So that's how we're going to be doing multiple things with quadratics. We're doing the quadratics topic right now. All right. So the question first says, we are to write this quadratic expression in this form, which really is to complete the square. Multiple ways to do it. There's a formula way to do it, and there's also a process way to do it. All right. So I think at AdMath, we learn the formula way, the process way. At CSEC, we tend to teach the formula way, but at this level, we tend to teach the process way. All right. So let's do it the process way. All right. So there's a formula for the H and there's a formula for the K that can be used. But we're going to do it the process way. All right. So they give us the f of x equals 3x squared plus 6x minus 1. And what it is, you want to be able to complete the square of the expression in form x squared plus nx. You want to be able to complete the square of an expression in that form. So we need to move the 3 from this x squared. We want to factorize the 3 away from those two terms because we're trying to get to this. All right? That's a method way. All right? So we're going to factorize away the 3 from these two terms right here. When it's a negative, you have to be careful. All right, factorizing away the 3, we're going to get x squared plus 2x minus 1. And then the process is quite simple. And it's basically a reversal of the process of expanding the perfect square. That's what completing the square is, a reversal of what you do when you expand the perfect square. All right? So this becomes equal to 3 into it's x, and then it's half of this coefficient in the bracket, half of it. So half of that is a plus 1. Then you add the square, and then you subtract the square of this expression. And the square of this expression, I'm going to write it this time, 1 squared. All of that, we have completed the square of those two terms, and then we need to put back this minus 1. Let me put in red what we did this time. We took half of this coefficient. Half of this coefficient. Come here, half of that. And then we subtract the square of this. We subtract the square of it minus the square of that expression. The square of whatever is here. Right? Doesn't matter whether it's positive or negative, you subtract the square of it. Doesn't matter. Because we are reversing what you do when you expand a perfect square. So you half this coefficient, that's a half, and you subtract the square of this. It's a two-step process, really. That's after you factorize away the constant in front of the x. Right? That's what you do. And then you're ready to expand. So it becomes equal to, I'm going to expand this 3 over this bracket. And so I'm going to get 3 into x plus 1. Don't forget the square. Then it's 3 times this negative 1 gives me negative 3. Negative 3 and negative 1 gives me negative 4. And that's it. I've completed the square. And so f of x is equal to this. All right? Then it says state the minimum value of the function. The minimum value is this. The minimum value is that negative 4. All right? The minimum value is that negative 4. Why is that minimum? That's because this part of it is a part that varies. And because it is positive, it can only be greater than or equal to 0. So it's like you start at negative 4 and you're always adding something because this part of it can only be greater than or equal to 0. So the lowest value that this thing in the box can be is 0. So the function is starting at negative 4 and then you're always adding to the negative 4 because this can only be positive because the a is positive, and that's why this is your minimum value. I said, we didn't know before, that is the reason. Simple as that. And so the minimum value is this -4 of the function, so part 2. All right? F of x minimum is that constant -4. And the terminal value of x when it is minimum. It is minimum when this expression is equal to 0. That expression is equal to 0 when the function inside here is equal to 0. And inside here is equal to 0 when the x is equal to the negative of this. So we can say, we can set it out like this. It is minimum. It is a minimum. You can say when. When is it minimum? It is minimum when the bracketed term is equal to 0, which is when the x is equal to -1. If we transpose the 1, and that is it. Let's say now the term that finishes that question. Done. When I do this one, we do quadratics. That's a quadratic inequality, no, not quadratic inequality. When I do this one, we do inequality. So we're not going to do this now. Even though it's a quadratic, we're not going to do it now. We're going to do inequality as a topic. Or we're going to do these linear inequality. We're going to do the quadratic inequality and the rational inequality. So we'll do this one. We'll do quadratic. We'll do inequality. This one right here. I better go to that. That's 2030. Everybody okay?
Yes,
Yes,
sir.
sir.
Yes, sir.
All right. Let's go to 2014 now. 2014. Okay, maybe take a look at quick short break after I finish this topic. After I finish quadratics. So 2014 next. Where are you? 2014 right here. 2014. Okay. So looking for the quadratics on this paper. Let's see. All right, so here is really a functions, which is not on the syllabus anymore. All of this part of it, not on the syllabus anymore. That's the polynomial. All right, quadratics is right here in number 2. Right, so it's basically the same thing, guys. So you see, once you do past papers in advanced, you're good to go. Advanced is easier than CSEC maths, and I tell people all the time, and I don't believe me. Advanced is easier than CSEC maths because I just keep repeating the same things over and over again. Right? The structure is the same, the order is the same, they're asking the same things with different values. Advanced is easier than CSEC maths. It's a much more narrow subject. It's easier by far. By far it's easier than CSEC. All right, ready? They give us this function. Now this one is a frown one because the squared term is negative. So it's a frown shape, so it will have a maximum. Again, they want us to compute the square right in that form. The process is the same, even though we have a negative there. All right, we just have to be careful when we factorize with -2. We just have to always be careful when we do anything with negatives. So f of x is equal to -2x squared minus 12x minus 9. So all the values are negative. But it's the same thing. We want to factorize away the -2 from these two terms. And because it is negative, we have to be careful. This becomes equal to -2 into -2 out of this will leave me with a x squared. But -2 out of this is going to leave me with a positive 6x. And that's where a lot of people make the mistake. They're going to put back minus for this one. A lot of people make the mistake and put back a minus there. It's a positive. And then this -9 comes back right here. They will proceed again, compute the square inside there, the normal way. Right? Half of this, and then subtract the square of what's in the brackets. Easy stuff. Equals -2 into x, because we're doing that. Half of this is a positive 3. Don't forget the square. Then subtract the square of this. Square of that is 9. Okay, I'm gonna put the -3 squared this time. Next time I'm just gonna put the value in. -3 squared. -3 squared. All inside the bracket, and then subtract back this 9. Right? That's why what we did this time again. Maybe next time I'm not gonna write it. I halve this value to get there. Then I subtract the square of this value minus the square of that value. It's a 2-step process. It's very easy. Nobody should get this thing wrong. Simple as that. Just make sure that when you factorize the -2, because it's negative, this change sign as well to positive. That is the only place anybody have the risk of making a mistake. Apart from that, everything is normal. Then this becomes, I'm going to expand with the -2 now. And so negative is going to give me a positive. Ready now? -2 into x plus 3 squared. This is -2 times -9. That's a positive 18. And then 18 minus 9 give me a positive 9. That's it enough. That's my maximum. This is now a maximum. You might ask, why is it a maximum? Plenty of people know it's a maximum when they negative enough. But let's reason it out just in case it didn't know. Let's reason it out just in case it didn't know. Why is this a maximum? The bracketed term here, the term that I placed in the box, that there is a square. It can only be greater than or equal to 0. Because it can only be greater than or equal to 0. And you're multiplying that value by this -2. It means that overall, if I were to include the -2, then this expression can only be less than or equal to 0. Can only be less than or equal to 0. Negative. So this will always be negative. And so you're starting at 9, and then you'll be subtracting from the 9. So this will cause the 9 to get less and less and less. So this in red will subtract from the 9. And that's why the 9 is your maximum. Because the thing in red is subtracting from the 9. It starts at 0, but then it only gets negative. And so it will subtract from the 9. And that's why the 9 is your maximum when the A is negative. All right, so that is it. So we didn't know before, that is why that's a maximum when the A is negative. It makes sense. All right, but that is it. But I want us to write it in this format, guys. So if you notice, I have a constant in front this time. So I'm just going to put the 9 in front here. I'm not transposing it in, I'm just shifting it around so it stays a positive 9. So to write it in the format that I gave me, I'm going to put the 9 in front, minus the 2 into x minus x plus 3 squared, and now it is in the same format as the heart there. But I feel like if you even left this, they would give you a marks. Believe me, they'll give you a marks as you see. All right? Then they say now, state the maximum value. So they be helping you. They're telling you that it's maximum. In CSEC, they might ask you to state whether it's a maximum or minimum. In advanced, they tell you it's a maximum. That to show you how easy advanced is. Right? Because I said this very same question in CSEC too, you know. So part 2, f of x max, maximum value of f of x is that 9. Same thing again, the terminal value of x when it is maximum. Same thing again. See? Let me repeat the same question. It's maximum when the term inside there becomes equal to 0. When the expression in the bracket there becomes 0. It's maximum when the x plus 3 is equal to 0, which is when the x equals -3. Done, that's it. Almost like the same question in 2013, just different values. That is why ADMAT is so easy. They repeat everything all the time. You see it? It's easy. I'm going to see it with all the topics. All the topics repeated all the time. Nothing magical about it. It's the easiest one. That was what? 2014. Let's go to 2015. 2015 is right here. Good. 2015. All right. So we still have to go working on the side here, right? Then I start the writing thing at 2016. 2015. Looking for the quadratics. All right. So there's no quadratic here. All right. There's no quadratic here. That's functions and logs and polynomial, right? Less than 2. Same thing again. All right. So this is a quadratic right here. Let's circle it. A is a quadratic. And B is a quadratic. B also is a quadratic system. It's a sum and product of roots. So we're doing A and we're doing B this time. All right. But C is a quadratic too, you know, determine the corners of quadratic. This is a quadratic too, you know, C. C is a quadratic as well, you know, equation of a line and a curve solve simultaneously. It's going to lead to a quadratic. So C comes under the topic of quadratic as well. So for this question, we're doing A, B, and C. A, B, and C, they all come under the quadratics topic. Right? Ready, let's go. So part A first. Same thing again. See, they give you that function, it's a quadratic, they want it to complete the square. See there, just have to put A, B, and C this time. They want it to complete the square. Same thing again, different values, same thing. So let's go. More maths equals better maths. Do it 1 million times to perfect it and master it. It's 3x squared minus 9x plus 4. More maths equals better maths. More times you do it, better I get, like signing your name. All right, same thing again. Factorize away 3 from these two terms. So this is equal to 3 into x squared. Factor the 3 out of this, I'm going to put negative 3x. And then I put the plus 4. Then I'm completing the square of these two terms. Equals 3 into x, half of that. I'm going to get a fraction this time, minus 3 over 2. Don't forget the square. And I subtract the square of this, whether it's positive or negative inside here, I still subtract the square of this. It becomes 9 over 4. All of that in the bracket, and then this plus 4 back out here, plus 4. Let's shift it over. Let's shift it over a bit. Running out of space. Let's shift it over a bit. So plus 4. Let's write it one more time what we did. One last time. Not going to write again after this. I took half of this coefficient here. And whatever sign is here, the same thing comes back here. So basically half of all of this that I put in the bracket there. Half of it. Then I subtract the square of this. Whether this is positive or negative, I still have to subtract the square of that value. That's completing the square. I'm not going to write that thing in red anymore after this. Must get it now. If you didn't get it before. I know most of you know already too, you know. But I still do. I still acting as if you don't know. Then we're going to expand with the 3. 3 times this is 3 into x minus 3 over 2 squared. And careful now. 3 times this. 3 times 27. That becomes minus 27 over 4 plus. This is 4. 4, because this is a denominator of 4. I'm going to write this 4 as 16 over 4. I get 16 over 4. I multiply under here by 4. I multiply up here by 4. 4, 4 is 16. So 4 is the same as 16 over 4. Because I want to have the same denominator as this one. So I'm going to write that 4. This 4, I'm going to write it as 16 over 4. So I can concentrate and work the numerator. So as a result, it becomes 3 into x minus 3 over 2 squared. Then it's 16 minus 27. Going to give me a negative, what is that? 11 over 4. Negative 11 over 4. Agreed? Agreed?
Yes, sir.
All right, that's it. So I've finished that part up here. The next part wants us to state the minimum value. This one didn't bother ask us for the value of x. Minimum value is this, negative 11 over 4. Same thing again, part 2. F of x min is negative 11 over 4. Done. And if I wanted the value of x, we can say when it is when the bracketed term equals 0, when the x minus 3 over 2 equals 0, which is when the x equals 3 over 2. If they wanted that. They didn't ask for this, but, good practice. All right, so this is the answer right there for that second part. So part A done. Part B now. Part B now right here. So part A done, and part B. The part B says this equation has alpha and beta as roots. Let's write it down. It's an equation, it's in the standard form, so we can say the A, the B, and the C. All right, so let's look at it this way now. All right, so it's 3x squared minus 6x minus 4 equals 0, and it has roots alpha and beta. We know we're going to need the sum of the product. So might as well just work the most from now. The sum of the roots, alpha plus beta, is minus b over a if you want to use a formula method. So it's minus, this is a B, you know, and this is a A. So it's equal to, have to be careful with the negative sign. Becomes minus and negative 6, that's your B, divided by A, which is 3. It's become positive 6 over 3, which is 2. And the alpha beta, which is your product, is C over A. This negative 4, just see, don't put 4. It is negative 4. Remember, the A and the B and the C comes from AX squared plus BX plus C equals 0. So the plus C is negative 4. And the plus B is negative 6. So be careful with those signs. So this then is negative 4 over 3. And this can simplify. So this is our alpha plus beta. This is our alpha beta. They want us to find this value, 1 over alpha plus 1 over beta. So what we need to do is take this and express it in a form inclusive of the alpha plus beta and the alpha beta. So basically it happens when you just add them and make it into one fraction, these two, 1 over alpha and 1 over beta. So we can say now, 1 over alpha plus 1 over beta. It becomes a classic fraction with the same denominator. Or we get it easy. Multiply this fraction by beta over beta. Multiply this fraction by alpha over alpha. Two denominators now equal alpha beta. If you want to show it the other way, by putting the beta over beta on this side, beta over beta. So you see the alpha beta, right? So it becomes equal to, this is alpha plus beta. So it becomes alpha plus beta over a common denominator of alpha beta. And so you're now putting this up here and putting this under there to solve it. All right. So it becomes equal to the 2, which is the alpha plus beta, divided by the negative 4 over 3. To simplify this quickly, I can invert this and multiply, or I can choose to multiply under here by 3, multiply under here by 3 to cancel this one, and multiply up here by 3 as well. All right, can do that. I'll just invert and multiply. It doesn't matter. This is going to become a 6. This cancel this. It's going to become 6 over negative 4, and which is negative 3 over 2. But we can just invert and multiply just to see. All right, that's not the only way to do it. So we can go and say it is equal to 2 times negative 3 over 4. Because negative 4 over 3 is the same as inverted to negative 3 over 4. And then 2 into this goes 2 times. So the final answer is negative 3 over 2. That's it. Negative 3 over 2 is the answer for that. But good? But okay with that?
Yes, sir.
Yes, sir.
All right. And then now come to this quadratic. This is a quadratic. This is a simultaneous equation leading to a quadratic equation. Simultaneous equation for curve and a line. All right. CSEC wrote this enough. CSEC level wrote this enough. This part is CSEC. This is CSEC and this is CSEC. A CSEC and C CSEC. All right. So let's do it. Part C. So part C, they give us two equations to solve. So one is 2x squared minus y plus 19 equals 0. The second one is y plus 11x equals 4. And I can solve them by adding, because right now if I add the two equations, this side and this side, the y will be eliminated. So I can solve it by adding this time. Sometimes you make y the subject, like 4 minus 11x, and then substitute this for the y right here. Right? But this time, it is set out in a friendly way for us. And so we can eliminate the y if we add the two equations right now. So I'm also going to add them. So I'm going to add the two equations, add them. So I'm adding add up everything on the left side together and adding up everything on the right side together. So on the left side, if I add up everything on the left side together, this is the only squared term there. So I'm going to write back 2x squared. This negative y and this y wipe out each other. This is the only x term there, so I'm going to write 11x. And this is the only number there, 19. And that is equal to, when I add up these on this side, get 4. I need to transpose that 4 because I want to bring it in the standard form. So it becomes 2x squared plus 11x. This 4 comes over to give me 15 when I subtract it. Plus 15 equals 0. So now it's a matter of factorizing. This can be factorized easily because everything positive, and this is a prime factor. So we know already that we're going to get 2x and x. Then we need factors of the 15 such that the sum of the far product and the near product is 11. All right, we want 11. So looks like I'm going to put 3 here and 5 here because this time that is 6, this time that is 5. 6 and 5 is 11. Signs are the same, they are both positive. So everything positive in this. So it's positive, positive equals 0. So I'm going to get x equals negative 5/2 from this factor. I'm going to get x equals negative 3 from this factor. Remember, you're not finished yet. You have to find a y value to go with this and a y value to go with that. You're solving a pair of simultaneous equations, and the question is asking you to determine the points of intersection which you get by solving them simultaneously. Points mean coordinates mean plus or coordinates mean x and y. Coordinates mean x or y. So I'm going to substitute these values in the line equation. Remember now, the line equation will be y equals 4 minus 11x. We're to transpose the 11x over here. And so, when the x is minus 5/2, y is going to be 4 minus 11 times minus 5/2. And somebody can just work that out for me. Quickly with the calculator. And when the x equals negative 3, the y is going to be 4 minus 11 times 3. 11 times negative 3. Careful. 11 times negative 3. That becomes 33 plus 4. So that one looks like 37. This one looks like 37, right? 37. So one of the points is negative 3, 37. It's one of the points. And somebody can tell me the first one.
63 and 2.
63 and 2, thank you. So the other one is negative 5/2, 63 and 2. So these are my two answers right here. This is one point, and this is the other point right here. Those are the 2 points. So that's quadratics in 2015. Voila, let's move to 2016. Quick and fast. We want to finish these and then the quadratics. So we'll take a short break and then we're going to move to another topic. Inequalities or sequence and series or something. We'll decide. 2016 next. We're going to do a number of topics tonight, a number of topics tomorrow, a number of topics Tuesday, Sunday, a number of topics Monday. All right? Tomorrow is what? Tomorrow is Saturday. So Saturday, Sunday, Monday. So 3 days. You must be able to finish all these questions as revision. All right? That's the aim, to finish all of the questions on these past papers. All right? So we can go in the exam nice and ready on Tuesday morning with a lot of confidence. Shot that exam to pieces. All right? Believe me, it's going to be basic. It's going to be basic. All right, so we're going to do the quadratics on this paper, 2016, which is right here. So this one says, determine the nature of the roots. Determine the nature of the roots. And the nature of the roots is determined using the discriminant. The discriminant of the equation is b squared minus 4ac. It's the same thing that comes under when you solve for the roots. And you put minus b plus or minus the square root of b squared minus 4ac all over 2a. Right? When you solve that, it is this thing inside here. It's this thing inside here decides how the roots are, that thing. It's called the discriminant. Right? So this is how you get the two roots. The plus gives you one root and the minus gives you another root. So that's how you get the two roots. So if this is greater than 0, then this gonna work. This square root thing is gonna work out. You're gonna get one root to the positive and one root to the negative. And so when this is greater than 0, the roots are real and different, right? The roots, when this is greater than 0, the roots are real and different. If the thing on the square root sign is greater than 0, I'm going to get one root to the plus, one root to the minus. If this is greater than 0, then this will work out to be a number. And you're going to get one with the negative and one with positive. So you're going to get two different roots. Then now, if this thing on the square root sign becomes equal to 0, then you're adding 0 and you're subtracting 0. And so in this case, the two roots become equal to each other. Because you're not adding or subtracting anything if the thing on the square root sign is equal to 0. So the two roots become equal to minus b over a, over 2a. Two roots become equal to that. And then now, if the thing on the square root sign happens to be less than 0, then you can't find the square root of 0. Or the square root of 0 is an imaginary number, and so you don't have any real roots. The roots are imaginary, the roots are not real, because you cannot find the square root of 0. And that's it, it's as simple as that. Then now, if you want real roots, then you want this under here to either be greater than 0 or equal to 0. The roots to be real is either they are real and equal or they are real and different. And so this thing under here is called the discriminant. It describes the nature of the roots. It's called the discriminant. And so this discriminant thing is really very easy. You just need to find out the b squared minus 4ac and see whether it's positive or negative. Or positive, negative, or 0. All right? So that's what it's all about. So if you want the nature of the roots, you need to find out what this is. B squared minus 4ac in this equation. In this equation, the a is 2, the b is 3, and the c is negative 9. And let's work out the discriminant. So the b squared minus 4ac, let's zoom this up, because I'm doing it right here. All right, so the b squared minus 4ac for this equation, remember you only get a discriminant from a quadratic equation, because it is only a quadratic equation that solves this way with the quadratic formula. So it's only a quadratic equation that can have a discriminant. Only a quadratic equation can give you a discriminant. All right. So anyway, so this discriminant will be equal to, the b is 3, so it becomes 3 squared minus 4 times the a is 2 times c. The c is a negative 9. I don't have to know the actual value. All I know that this minus is going to make this side a positive. And so I know that this is going to work out to be greater than 0. This will work out to be greater than 0 because this thing is positive, has to be positive. I don't need the actual value. And once the discriminant is positive, the roots are real and different or distinct. Two different roots. Roots are real and different, or you can say distinct roots, meaning they are different. Real and different are real and distinct. Simple as that. 1 mark for it, but the 1 mark. I'm just take our time to explain it, just in case anybody here don't know. But I go to that.
Yes, sir. Yes, sir.
All right. Here now they said they want us to sketch the graph, sketch it, and they want us to clearly indicate where the minimum point is. That's all I want, the minimum point, right? I would know that it's going to have 2 real roots, meaning it's going to intersect the x-axis at 2 clear points, right? And the minimum point is going to be below the x-axis. That's what we know for sure. But it's a smile shape function, you know. This is a smile shape function. See, because the square term is positive, it has 2 real roots, and therefore it must come below the x-axis in order to have 2 real roots. The roots correspond with the points where the graph intersects the x-axis. So the roots correspond to those points. So the minimum point is going to be below the x-axis. So they want us to sketch it. So we're going to show the minimum point, guys. Then we need to know what the minimum value is. We can calculate the minimum value now. The minimum value is a k value in the formula, which is 4ac minus b squared over 4a. But you can complete the square and get the actual point. So again, you can complete the square. If you complete the square, we'll see where the minimum point is. So we're going to complete the square of this thing. All right? Since that's on the syllabus, that's the method we're going to use. So it's the same thing again. We're going to write f of x as factorize out the total of these two terms, and we're going to get 2 into x squared plus 3 over 2, all in the bracket, minus 3 over 2x. Let's leave off the x, 3 over 2x, and then minus 9. Then we're going to go and write 2 into, complete the square here, you're going to get x, half of this is 3 over 4. You won't forget the square, and then subtract the square of this, which is now 9 over 16. And then you're subtracting this 9 out here. I'm going to expand with the 2 now. When I expand with the 2, I'm going to get 2 into x plus 3 over 4 squared. Then this times this give me 9 over 8. That's negative 9 over 8. I want this to become something over 8. I'm going to multiply by 8 over 8. It becomes 72. So I'm going to put minus 72 over 8. And so it becomes 2 into x plus 3 over 4 squared. And this one is giving me much? 91? No, 81? Got it? Minus 81 over 8. All right? So it means that this is my minimum value, which is basically 10 and 1/8. That's what it is, 10 and 1/8. And it is when this equals 0. So I can write my minimum over here. My minimum point is going to be where this equals 0. The x is going to be negative 3 over 4. Negative 3 over 4. And this is my minimum value. Negative 81 over 8. All right. Another thing we need to know is that this negative 9 is your y-axis intercept, because it is when the x value equals 0. So it also passes through the point 0, negative 9. And then it smiles. It has a smile shape. Smile because the square term is positive. So I'm putting these things down because they say to sketch it. Right? And they don't give us a lot of space to sketch it. Right? So this information is needed to sketch it. As I said, I could have calculated these values using a formula method, but because it is completing the square that is not a syllabus, that's why I do it that way. So that's sketch. You don't have to be to scale. So I'm going to write an x-axis. I'm going to just sketch an x-axis and a y-axis. It's not to scale. I just need to get the right shape and so on. So this point will be in this quadrant down here. Negative 3 over 4 and negative 81 over 8 will be somewhere in this quadrant over this side. So turn somewhere down here. And then this point will be somewhere down on the y-axis down here, 0, negative 9. And the graph has a smile shape. So we're just doing a sketch and putting on those values. So we're going to turn it here like that. Let's do it again. Something like that. And I'm going to label it. This is going to be 0, negative 9. This minimum point is going to be negative 3 over 4, negative 81 over 8. Right? And this is a sketch of the function. This is the y-axis, this is the x-axis. I'm going to see this is a sketch of f of x. Done. If they ask me for the roots, I would have to solve the equation. For example, solve this equals 0, or solve this equals 0. This one to find the root. But the question clearly didn't ask for the root. They said what they wanted. They wanted only the minimum value. So that is it. That's my sketch. Quadratics, 5 marks to do that. Bang, bang, bang. All right, so that's quadratics on that paper finished. We're going into series down here, so now, and then over here now is our coordinate geometry. So 2017 paper now, 2017. Remember, we break after this topic, short break after this topic. 2017. I'm going to finish 3 or 4 topics today and narrow down on the topics, right? As we get to the exam. I'm going to do all the topics, every topic between now and the exam, 2017. Every topic I want to cover. I want to do every question in this revision period between now and Monday. All right, so let's go. I know you have other exams to do. All right, but we're just working on this thing. All right, this is a quadratic. This is a quadratic sum and product of roots. So we can work on the paper again. So these are similar questions. So you see, that's why ADMAT is easy. So it's basically the same. They give an equation and again the action. We just do one like that a while ago. Later we can write what this is equal to now. We just do one. This is equal to alpha plus beta over alpha beta. It's equal to that, right? Because the same thing again. It's just 1 over alpha plus 1 over beta. And then the alpha plus beta is minus b over a. So it's minus 6 over 2, which is negative 3. And the alpha beta is c over the a. So it's 7 over 2. And so this becomes equal to the sum, come up here, which is negative 3, over this goes under here, which is 7 over 2. And so this 2 can invert and multiply by the 3 up there. And so the answer is negative 6 over 7. Done. That's finished. Just like that. Soft, nice and easy. 4 marks. Eh? This, I did one a while ago. Yeah, you want to show it still, you want to show you get it. But they can't penalize you for advanced knowledge. If you just write this down, you know. Because that is something that somebody can just know. If I was in the exam and I want to show it quickly, I might maybe just do this. In the exam, I'll leave this on the paper. Just put a beta over beta right here and an alpha over alpha right there, and then to be clear. Understand? Can you make this a part of your solution? You get me? Make it a part of your solution. So you want to show something, that's what I will do. Cut down the time, get the 4 marks, become fast. We'll do this in another question. Let's see if there's any other quadratics here. Doubt it. This is a serious question. All right, and so that is done. 2017 quadratics done. That one question right there. All right, so let's go to 2018. 2018. Where are you? 2018. Where are you? Right there. 2018. All right, let's see now. All right, here's a quadratic. This part of it is linear reduction. All right, so quadratic is right here. And I want to do a sketch. Should give you a graph to do a sketch. All right, let's see. It says, give this function that's a frown, because the square term is negative, we can see that. Express it in this form. So they want us to complete the square, right? Same thing again, complete the squares already. So here now, we're gonna have to factorize a -1 because the coefficient of this x squared is really -1. So you have to be careful. Now factorize away a -1, right? So we're gonna get this being equal to -1 into x squared, and when you factorize -1 from that, become -x. That's where a lot of people make the mistake and put a plus. All right, and you put -3 back out here. Equal -1 into x, and then half of the 1 in front. This is a 1 in front there. Don't see it, but there's a 1 in there. So it becomes -1/2 squared. Then subtract the square of this, which is a 1/4, inside -3. Then expand with the -1. I get negative times this, which is -x - 1/2 squared, this minus give me a positive quarter. I'm going to write this now, right now, as instead, I'm going to write it as 12 over 4. So this, I'm going to write it as 12 over 4. I realize that it's going to be over 4. I'm going to write this 3 as 12 over 4. I had 3. I want 4 under here. I'm multiplying here by 4. I'm multiplying here by 4. It becomes 12 over 4. So I'm writing that 3 as 12 over 4. And then ready now. So it's minus and minus 1 give me positive 1. Positive 1 minus 12 is negative 11. All right, so positive 1 minus 12 is negative 11. So I get the negative 11 over 4. That's what I get. That's it. This is this. That's it. Want to go do that?
Yes, sir.
Then it says, on the grid provided below, sketch a graph showing the maximum point and the y-axis intercept. So the y-axis intercept, now based on this, let's see what the maximum point is. The maximum value is this, which is when this equals 0. So it's going to be, the maximum point is going to be when this equals 0, that x value is a half, and this is the maximum value, right? Which is negative 11 over 4. So the thing about this now that the maximum point is below the x-axis, right? The maximum point is below the x-axis. And then the y-axis intercept now corresponds to this negative 3 because when x equals 0, so that y-axis intercept is 0, negative 3. Well, this is now what? This is 2 3/4, right? Negative 2 3/4. And they give a scale. I don't know why they put a scale. They give a scale. Well, let's put where the points would be. Let's put where the points would be. So the y-axis intercept, let's use it. Y-axis intercept would be negative 3 right here. That's where we got the y-axis. And this turning point is going to be half. So half right here. So negative. No, negative 11 over 4 is the same as negative 2 3/4. Negative 2 3/4. So it's just negative 2, negative 2 1/2, negative 2 3/4 around here. So we're talking about somewhere here. Let's zoom it up. Let's zoom it up so you can see what I'm talking about. I'm looking for negative 2 3/4 for the maximum point. So I'm saying this is negative 2. Here be negative 2 1/2. So negative 2 3/4 be halfway between here and here. So approximately it's about here. And it's at a half. So that maximum point is somewhere around here. That's where it turns. Right? And then we're going to pass through here and pass through there because it is symmetrical about this line. Right? So if I were to sketch something, it will go something like that. Well, suppose because they gave me these values, I'm going to actually work out some of them. I'm not going to sketch it. I know that this is 1 point and this is 1 point because of the symmetric nature of the function. This becomes your line of symmetry through the vertex. Your line of symmetry is through the vertex. So if this is a point, then this right here is a point, symmetrical from the line of axis of symmetry, the vertex line. So I know it passes through those points right now. Let me erase this. Right? I'm going to pass through these points. But for the simple reason that it gave me on a graph, I feel I must give them something accurate. So I'm going to work out for this. And if I work out for that, I automatically, and if I work out for that, there's a half. If I work out for that one, it's basically 1 from here. So it's 1 from here. Whatever this value give me, it's going to be the same thing. I can work out for negative 2 as well. Simple because they give me the graph. So I want to know the actual values, right? I want to know the actual values. So I'm going to work them out. Right? So where's the function again? Function is right here. This is a function. I can use this one, just the original one, just the same. So we can use minus x squared plus x minus 3. I'm going to work out the values, work out some values. So I'm going to put in 2 in there. So put 2 in there, x equals 2. If x equals 2, this becomes minus 4 plus 2 minus 3. That becomes what? Negative 5, right? Minus 5, don't it? Minus 5. So 2 is minus 5 right here. I'm going to at least put on this point right here. But because the graph is symmetrical, 1 across down here. Then from here, 1 across going to come right onto the same place here. So this is going to be a point on it as well. But the graph is symmetrical. It's a symmetrical graph. It's symmetrical about this line. And then I'm going to stop it right there. Bang. Bang. Something like that. And I give them that as my graph. Right? At least give them another point that is accurate. And that's my sketch. Yeah, because I can't draw it neatly. CSEC don't care about whether it's beautiful or not, eh? They just want to make sure you put on the right point. So this is my maximum point. And I stated the coordinate up here. I'm leaving this on my paper. I'm not going to erase it. I'm leaving it right there. Right? And this is my y-axis intercept. I'm leaving it there as well. So these things that I put on the paper here, I'm leaving them and not erasing them. That's my maximum, and this is my y-axis intercept. My actual y-axis intercept as well, I've stated it here, and I've shown it right here, my y-intercept. All right, that is it. All right, I think that finishes that question. This is a GP. 2018 done. 2019. 2019. 2019, 2019, where are you? Right here. 2019 quadratic. Let's see. 29. This is a quadratic right here. We're looking at right now. That's a quadratics. Let's see, there's another quadratic. Well, all right. Well, this really is a functions. This really is a functions question. I'm not gonna do it because it's really a functions question. But this part is a quadratic, you know. So say you put this and show say it equal that. Really a quadratic. So we can do it. We can do that part of it as a quadratic. Let's see if there's any quadratic proper on the paper. That's a really a functions. That's logs. But this is really the quadratic on the paper. So let's do it right here. This is really the quadratic on the paper. So again, I want to complete the square again. Let's do it. More maths equals better maths. So let's do it again. And we're going to factor out the negative 2. I have to be careful because it is negative. So this becomes equal to negative 2 into x squared. When you divide this by negative 2, it becomes a positive 7 over 2x. And you have a minus 6 out here. Complete the square inside here now is negative 2 into x. Half of this becomes 7 over 4 squared minus the square of this is 49 over 16. 49 over 16. And all of that is inside the bracket. So if I look ahead, I know that when I multiply this by this, I'm going to get something over 8. So I'm going to express this as something over 8. And that is 48 over 8. But I get that the 6 is 48 over 8. Because when I expand now, I'm going to get minus 2 times x plus 7 over 4 squared. This time, this is going to give me positive 49. 49 minus 48 is going to be 1. I'm going to get plus 1 over 8. That is it. Better go to that?
Yes, sir.
Good. State the maximum value. Bang! 1 over 8. Just state it. And let's write it here so you know 1 over 8. 1 mark for that. Let's write the 1 over 8 there. So state the value of x when it's the maximum. Maximum when this inside equals 0. It is when x equal, no, when the x plus 7 over 4 equals 0, or you could just state it and write x equals negative 7 over 4. Use the answer sheet to determine all the values of f of x equals 0. Use the answer in A1. So they want us to use this. Find all the values when f of x equals 0. And it's just 2 values as a quadratic. So basically, I put in this thing equals 0 down here. That's what we're doing. Right? F of x equals 0. That's what they want us to do. They don't want us to use the quadratic formula. They want us to work from here. All right? So we have minus 2 into x plus 7 over 4 squared plus 1 over 8 equals 0. That's what we're solving. All right, so when we transpose this, become negative 1 over 8, and then we divide by negative 2 becomes positive 1 over 16. Then we can see that x plus 7 over 4 squared equals 1 over 16. Agree with that? But I agree with that? But I agree with that?
Yes, sir.
We're gonna square root this, and we're gonna become positive or negative a quarter. And then we're gonna transpose this 7 over 4 afterwards. It's gonna become negative. So the x is gonna be negative 7 over 4 plus or minus 1 over 4. But I can agree with that?
Yes,
Just
sir.
a small amount of space, right? So we can write now that, let's use a different color just to emphasize now. From here, you're gonna get 1 with the negative, 1 with the positive. So it's negative 7 plus 1, that's negative 6. Negative 6 over 4 is same as negative 3 over 2. The one value is that x equal negative 3 over 2, and other one is with the minus down here. The minus. So negative 7 and negative 1, that's negative 8. Negative 8 over 4 is negative 2. So the other value is that x equals negative 2. These are my answers right here. These two values are my answers. Negative 3 over 2 and negative 2. But go to that? But okay?
Yes, sir.
All right. Another thing them say now,
Sir.
sketch a function. Yes?
Sir, could you go back, please? Sir, in the last line where you have the negative 7 over 4, but it isn't squared, how did that happen?
All right. So when I have to get rid of this, I have to square both sides, right? So when I get rid of the square, this became the plus or minus a quarter. Can you see that?
Yes, sir.
And then I would have this on the left side. And so when this 7 over 4 came over this side, it became negative 7 over 4. See it?
Okay, sir. Yes, sir.
See it now, you sure?
Yes, sir, I do.
I took all those shortcuts because the space is so limited. So CSEC, you don't really want you do no whole heap of steps, you know. Okay, doing the math like big children, right? So you have to be able to just do multiple steps at once. But if you're not sure, you cut the page in half, the sum of it over here, and the sum of it over here, okay?
Okay, sir.
Steps. Good. Do it like that. All right, let's continue. Then it says now, sketch a function and show solution set for f of x less than 0. Now remember, this now is going to be between the two roots. F of x less than 0 is between the two roots. And it's a maximum. It's a maximum function. So it's going to be outside the two roots as a frown. It's a frown, right? It's a frown. Yes, it is a frown. All right, so they want us to do a sketch. So we know that the maximum point is with this x value and this y value. Let's write it out. Let's write down some stuff. The maximum point, let's write it down here. Maximum point is negative 7 over 4, 1 over 8. And the y-axis intercept based on the function. What is the function again? Constant in it was negative 6. 0, negative 6. 0, negative 6. It passed through 0, negative 6. And then these are the two roots. Those are the two roots, you know. Those are the two roots. So those are the two roots. And so we can leave them there. So they want us to sketch it. So let's put the y-axis. Let's put the y-axis. And let's put the x-axis. So it's have a small maximum value. So it barely goes over the x-axis, right? Barely goes over the x-axis. So we can put it like right here. X-axis. So that's the y-axis, that's the x-axis right here. Then now, the maximum point is negative 7 over 4, 1 over 8. So it's somewhere over here. Let's put it in red now. Somewhere over here, turn somewhere over here. So, right? Negative x value, positive y value. And then now it has two negative roots. It has two negative roots. Negative 3 over 2 and negative 2. So it cut the x-axis somewhere here and over there. And then it cut the y-axis at 6. 6 or negative 6? Negative 6, not 6. Negative 6. Didn't make any sense. So it's negative 6 right here. Let's change it. Negative 6. So it cut the y-axis at negative 6 down here. Negative 6. So it has a small turning point up there, so and cut the y-axis somewhere down here, and it frowns. So basically, I want to sketch something like that, right? So let's take off back all those points and let's sketch it. And then put in the points after. Don't put in the points first. Sketch it and then put in the points. Easier. So it's going to go something like so. Something like that. Then let me shift over the y-axis. More to the right. Over here. More on the left side of the graph, right? So let's do this way. Let's sketch it. So it goes something like that. Not so beautiful, but it don't matter. They're not giving marks for aesthetics, guys. Something like that. Can I get it right? All right, I'm going to leave that one. So this is a y-axis intercept, 0, negative 6. These are the tools. I put them right now. The negative 3 over 2 is closer to the y-axis than the negative 2 down here. Those are the tools. This is the maximum point. This is the maximum point. That one there. This is negative 7 over 4, 1 over 8 is that maximum point. All right. Then this inequality now, we want a solution set for it, right? Let's put it on back in. Let's show it in purple what it's talking about. It's talking about where the function is below the x-axis. So it's basically talking about this part of the graph and this part of the graph. Those parts of the graph, the y values are less than 0. And you're not including the 2 points because on the x-axis, the y values are equal to 0. So this part of the graph is obtained by x values to the right of this root, which means x is greater than negative 3 over 2. And this part of the graph is obtained by x values to the left of this root, which is where x values are less than negative 2. So these form your solution, but they said I want the solution set. So the solution set is obtained basically by putting the solution in set brackets. Right? So you could write something like this. Solution for f of x less than 0. Solution set for that is x is such that it is less than negative 2, or you put the union for or, it is greater than negative 50 over. It's greater than negative 3 over 2, and you put the set brackets around it. And that's the set notation with your solution set. This is a union symbol for or. That's it. This is union, guys. Union. My pen don't work so nice, guys. You don't write how I write, Just one thing. All right. So you have to bear with me. That's a union symbol, union. But understand that? That's a solution set. Whenever they ask for a solution set, you have to put the solution in set brackets. And you say x is such that, and you write the inequality that you have. It's set notation. But okay?
Yes, sir.
Yes, sir. You have to write the union, something say.
Yes, union. Don't write or. Use set notation. Syllabus, you must use set notation. I bring up the syllabus right now, you'll see it. When they ask for solution set, you have to use set notations like this and set notations and stuff like this, like he's a member of R and all these things. You have to write those set notations. Okay? Don't write the word or, please. All right? Okay. Syllabus says use set notation. This is a set notation. Those are set notations. All right, so that finishes that one. So that is 2019. Let's go now and look at 2021. Remember, there's no paper 2 in 2020. All right, so we're going to look at 2021. 2021 is right. Where is it? 2021 right here. I'm going to take a break after finish 2022, right? Quadratics. This is a quadratics question right here. It says a function, this as a function, and let's say they put it equals 0, which has real and equal roots. Let's have real and equal roots. It means that the b squared minus 4ac is equal to 0. So this part of it, and the equation part of it has roots. So what about the function part? The equation part of it, they set a real and equal roots, so the b squared minus 4ac is equal to 0. It says use the discriminant. See here, I'm telling us to use the discriminant. Use the discriminant of the given equation to determine the value of m. You may use the grid provided to assist you. I don't see why they need the grid, don't need to assist you. I don't need it. This is foolishness. I don't need that. All right? They want us to determine the values of m. That's all we need to do. Discriminant equals 0. I don't know what that grid is about. Right? So we're solving this basically. B squared minus 4ac equals 0 because it has real and equal roots. Real and equal roots. So we're solving b squared minus 4ac equals 0. So the b is 4 plus m plus 4. So it's m plus 4 squared minus 4 times a. In this equation, there's no number in front of the x, so the a is 1 times c. This is just c, 4m times 4m equals 0. That becomes a quadratic in m. I can solve it. It's a quadratic equation in m. So I'm going to expand it out. Let me shift this up. Let me just shift this up here. That's what we used. Just to get more space, guys. I'm shifting this up here. I'm going to shift this here. Just to get more space to write. All right. I'm going to expand this out and solve it. It's a quadratic equation. So this guy's quadratic equation. I was expand it out in the standard form and then solve it. Don't try to solve it until you put it out in a standard form. If you recognize it as a quadratic, because this produces a square term that produces a m term. So this expands out into m squared plus 8m plus 16. But I give it that.
Yes,
this
sir.
expands out to that. Good. But everybody don't get that, right? There's nobody on the call don't know how I got that, right? The first term squared, the middle term is twice the product of these two things, twice the product of the 2. So we get this middle term is to multiply these two things, they get 4m and they double it to 8m. And then this 16 now is the second term squared. That's what you do when you expand a perfect square. This becomes minus 16, 4, 4 is 16. Minus 16m equals 0. Put it in the standard form. M squared. Consolidate these two, I get minus 8m plus 16 equals 0. Now I'm going to factorize this. Factors of 16 that add to 8. Always add, because it's a plus. That's 4 and 4 now. So it's m, 4 and 4, signs are the same, they are both negative. That's a perfect square. So we get m equals 4. This give me m equals 4 and this give me m equals 4. So it's m equals 4 repeated. Why did I say repeated? Because it came from a quadratic equation. So the 4 is repeated and this said values plural. So it's m equals 4, m equals 4. Determine the values of m by plural. Another quadratic right here. Lovely. Get to on this paper. 2021 people lucky. They wanted to complete the square of this again. More maths equal better maths. Let's do it. So if we complete the square of this, firstly, h of x will be, you're gonna factorize the 2 from these two terms to get 2 into x squared plus 4x minus 10. Complete the square of here now, you get 2 into x, half of this positive 4 is positive 2 squared minus the square of this 2 is 4, and then subtracting 10. Ready to expand. 2 times this first is 2 into x plus 2 all squared. 2 times that is negative 8. Negative 8 and negative 10 is negative 18. Done. That is it. State the minimum value. Bam, that's here. Negative 18. Let's write it. Negative 18. Just state it. State. Missing have to calculate nothing. That's it. State the value of x when it is minimum. It's when this equals 0. So it's when x equals negative 2. X equals negative 2. Or you could just write negative 2. Just state the value of x. Negative 2. So you can just write negative 2 and get the mark the same. 1 mark for it. That is it. Right? So that is it. X equals negative 2. Why do I go to that? Because it is when the x plus 2 equals 0. That's when it is minimum. When the bracketed term equals 0. Done. 15 marks for that question. All right, that's 2021, 2022, and the specimen, and then we take a break. All right, 2022. 2022. This is last year. Let's see what they said on this. So just do this one. And let's see if there's a quadratic in number 1 first. It's a series. This is a quadratic in a sum and product of fruits. So sum and product of fruits that we're talking about. Let's see. Right. This is a quadratic, guys. Yep. It's a nice looking quadratic. Let's see. This is a nice looking quadratic. This one says, consider the quadratic equation. Bang, that's a quadratic equation. Where P and Q are both positive integers. So these are both positive integers, meaning they are greater than 0, both of them. Oh, this can be done multiple ways. This is already starting to look like x squared minus the sum times x plus the product equals 0. So we can just carry to that way and done. Right? I can just divide 2 by the q. If I divide 2 by the q, it's going to become x squared minus 4p over q x plus divide this by q. It's going to become pq equals 0. So it means that this is my sum and this is my product, because it is in the form x squared minus the sum times x plus the product equals 0. So this is my sum and this is my product. All right, so I'm going to just write that. So I'm going to write that my sum is equal to minus 4p over q, and that my product is equal to pq. Let's check and make sure that is correct. So I divided 2 by the q. So you're going from there, came on left here and cancel out one of that. PQ. That's it. But understand that if you wanted to use the minus b over a, you get the same thing for the sum, because then you will get minus 4p. You'll get minus 4p, right? You'll get minus and negative 4p, because the b will be negative 4p over q, and the minus becomes a plus. So I made a mistake. This is supposed to have the minus, and it is this. Good thing I double checked it. This is supposed to have the minus, and it's just 4p over q. Good thing I double checked. And then now, so it will become minus negative 4p over the a, which should have been q. So it will equal that. And then the product will be c over a, which will be pq squared is a c over q, which is a, which will become pq. All right, but by putting it in that format, we can just write this. All right, which I think I would prefer it that way this time. So once the equation is started to look like this for me, I'm going to work with it. Now, next one. Determine the value of Q such that the sum of the product is equal to the product of the roots. Let's read this again. It says determine the value.
That says minus 5x.
Where? No, this is a S. This is a S, sum. S for sum. This is a sum. This means this is S for sum. Not 5, it's a S. S for sum. S. A quadratic equation can be written as x squared minus the sum of the roots times x plus the product of the roots equals 0. If you want to write this same equation in terms of the alpha and beta, right? It can be x squared minus alpha plus beta. X plus the product is alpha beta equals 0. That's another way you can write it. Let's write this square properly. So a quadratic equation can also be written in this format if alpha and beta are your roots. So you see, this is the sum of the roots, and this is the product of the roots. So a quadratic equation can be written in that way. That's when you start with an x squared. When you start with an x squared, you can written like that. It's the same thing, basically. All right. So they actually ask question like this on the multiple choice, you know. They ask, and also this, they present this on the multiple choice often as well. So you have to get familiar with them if you're not. All right. All right. Back to this question now. That answers the question. You okay?
Yes, sir.
All right. Determine the value of Q such that the sum of the roots is equal to the product of the roots. So the sum equal the product. That's what they're saying. So it means that this equal this. We want to solve that. So basically what they're saying is that 4P over Q equals PQ. So what will happen is that the P's will cancel on both sides, right? Because they told us that they are positive values. And so we can divide them out. So the P will cancel that. And they're going to get Q squared equals 4. And because it's positive, the Q will be equal to plus or minus 2, you know. But the Q is greater than 0 because they say positive. Therefore, the Q is just simply equal to 2. So the Q is 2. But understand that?
Yes, sir.
Yes, sir.
All right. Next part now says, if the sum is 20, use the answers in A2 to determine value of P. Now, what do we have? We have Q equals 2, right? We have Q equals 2. And now they're telling us that the sum of Q equals 2, shift this over. So we have Q equals 2, and then now tell us that the sum is 20, right? And the sum equals 20. What is the sum again? The sum is this guy here, 4P over Q. So it means that 4P over Q equals 20. And this is at 200 years, right? Don't it? If that is at 2, it means that 2P equals 20. So P equals 10. That's all. P equals 10, right? But I give that? So P equals 10. All right, good. So P equals 10 and Q equals 2. Hence, express the given quadratic equation in terms of the numeric coefficient. The given quadratic equation, what did they give us? They gave us this guy up here. So we need to put in the values. I'm going to write it out and carry it down. So they gave us QX squared minus 4P X plus PQ squared equals 0. And I have a bracket around here. Let's copy this down. That's what they gave us. I'm going to put the values in it now. Copy, paste it down here. So in this part, paste. All right, so that's what they gave us. And we are dropping in the Q equals 2 and the P equals 10 in there. All right. So if the Q is 2, that becomes 2x squared. Bam. If the P is 10, that becomes 40. And then if the Q is 2, oh, them two are equal, you know. All right, them two are equal, remember? So if the Q is 2, this is 4, and this is 10. So 4 times 10 is 40 equals 0. So that's the given equation. So I want to leave it like that. can be divided 2 by 2, you know, but they say they give the equation, so leave it like that. That's what they said. Done. I like it. I like this question. They try to put a little sugar on it. That's what I like about it. It wasn't just straightforward like that. They had a little sugar on it, make it nice. All right. That is 2022. And then we're going to do the specimen paper. Specimen paper quadratics, because I can show you that there are questions on the specimen paper that are very similar to what you get on the exam. This one here, so right off the bat. Right off the bat, there's one. Still similar. It's a specimen paper, you know, guys. And right here, this question is similar to what we just did. The M business, and they give the equation. But this time I said function g of x is this. You say they put equal 0 again, but this really is the equation. That is the equation right there. And they say it has real roots when b squared minus 4ac is greater than 0. Why is that? See, real roots. Real roots mean that it can be real and equal or real and different. So when the equation has real roots, then the discriminant is greater than or equal to 0. Okay, taking both into consideration. You're taking into consideration that it could be real and equal for the 0, or it could be real and different for the greater than. So you combine them to get the real. Real alone. Real means real and equal, or it could be real and different. And that's when we use the greater than or equal to. So when the roots are real, if all you know is that the roots are real, you have to put greater than or equal to. Good. It says the function that has real and equal roots when b squared minus 4ac is greater than 0. Determine the range of values of m. So basically, we want to set up this inequality and solve it. That's what we get the range of values of m. All right? So we're working from here. So we're going to work from here and solve this. That's what we're working from. We're setting that up and solve it. All right? So what is the b squared? This is m. So that becomes the b squared. So we're going to get m minus 3 squared. It's a quadratic inequality still, but no matter. We're going to do this. It's an inequality. We're going to do it still. So we're going to get m minus 3 squared minus 4 times the a. The a is 1. Coefficient of x squared is a 1. Times the c, which is 2m minus 1. Careful, it's 2m minus 1. 2m minus 1. That's b squared minus 4ac. Let's say it is greater than or equal to 0. So what we have formed is a quadratic inequality. What you're going to do, expand it out again and set it out in the standard form. We can make the sketch to represent the region that we want. So we're going to expand this side. We're going to get m squared minus 6m plus 9. And we expand this now, that's a negative 4 over that bracket. So negative 4 times 2m is negative 8m. Negative 4 times negative 1 give me a positive 4. This is all greater than or equal to 0. Consolidating, it's m squared. Then this and this is negative 14m. Then this and this gonna give me 13 plus 13 greater than or equal to 0. This can be factorized. That's a prime number. 13 and 1 are the factors, and they add to 14. So it's easy to factorize this. M and M, 1 and 13. Signs are the same. They are both negative. Signs in the bracket are the same. They are both negative, greater than or equal to 0. If I were to sketch the graph of that based on these two roots, the roots from this one are the critical value from this one, the 1, from this one, the 13. And to be a smile function, this quadratic inequality related to a smile function. So my sketch, if I were to put it over here in red, would be like this, smile. It's the m axis because I'm doing a quadratic in m. I want a critical value of 1 from this factor and 13 from this factor. I'm shading here because the equal is a part of inequality. So I also need the values at 13 here. Greater than 0 means that I want, let's put that part in purple. I want the part of the graph up here and up here, which are obtained by values to the right of 13 and to the left of negative 1. Let me shift this down. squared. So it's m greater than or equal to 13. And I can't see that. So let me shift this around. Sorry about the noise, guys. The dog is here getting crazy. Sky Alex's dog getting crazy. But she's not attending to him, she's in the class. All right, so over here now, the m is less than or equal to 1. If they want a solution set, they just want to determine the range, right? They just want the range. So if we were to write the solution up here in this box, solution, it will be x, not x, m less than or equal to -1 or m greater than or equal to 13. And that will be our answer right there, based on this sketch. But go do that?
Yes, sir.
Yes, sir.
Beautiful. All right, and we have this quadratic down here, which is to complete the square of this again. No problem, let's do it. More maths equals better maths every time. The more we do, the better we get. Complete the square of these two. We're going to factorize away the 3 first. H of x will become 3 into x squared plus 4x minus 18 over there. Complete the square inside here. 3 into x, half of this 4 is 2. Don't forget the square minus the square of this is 4. Inside and subtract that 18. Then we expand. See, don't get a lot of space to work with. We're going to expand 3 times this first. Let's put just 1 thing. 3 into x plus 2 squared. This is 3 times, that's 12. 12 and 18 is 30. So it's minus 30. But I get that?
Yes, sir.
And the minimum value is this negative 30. So it's minus 30. And the terminal value of x, which is minimum, is when this equals 0. And so it's when x equals negative 2, because it is when the x plus 2 equals 0. So it's when x equals negative 2. That is it. All right, guys. Let's see if we can quiet down the dog a bit. So we'll take a short break. 10 minutes break. Don't want to break too long. 10 minutes break. And we're going to come back and we're going to go on to which topic we can go on. We can maybe go on to series. Or maybe inequalities. Inequality, you're not going to find a lot of inequality. We can maybe go on to series next. All right? Sequence and series. AP, GP, summation. Series next, okay? But we're going to do that?
Yes, sir.
So what time is it now? It's now, all right, so start back at 9. Start back in the next 12 minutes. It's now just 2 minutes to 8:50, 7:50. We're gonna start back at in 12 minutes time. 12 minutes, you're getting a 12 minutes break, okay?
Okay, sir.
All right, cool. This polynomials done. Quadratics done.
So, sir, log off and log back on.
Ah?
Log off and log back on.
No, you don't have to log off. You can stay on, man. You can stay on. You don't have to log off. I'm just gonna mute the mic up. I'm just gonna mute the mic a bit. But you can stay on, not a problem. You can stay on. It's gonna take a 10 minutes, 12 minutes break. So we're gonna come back on the series. We're gonna do the series. AP, GP, and summation. All right? That's what we're gonna do next. AP, GP, summation. We're gonna drill down at all the topics until we finish all of them. We're gonna eventually come to trigs. We're gonna come to coordinate geometry. We're gonna come to vectors. We're gonna come to differentiation, integration, surds, logs, indices, kinematics, statistics, probability. We're gonna do all the topics between now and the exam. All the topics. So get some good revision. All right. I'm just gonna just mute the mic now. I'm gonna try to settle this dog. All right. Okay, guys, time again. Nobody there with us? Good and ready?
Yes, sir.
Yes, sir.
Can you hear me? Can see the screen still. Everything's still good. All right. So we're going on. There was no serious other questions. So we're doing logs. We will do that one. All right. So let's go. So one of the straight serious questions, we're looking for summation. Looking for summation. This first one is a GP. All right. It gives us this series, and it says we are to show that it is geometric. So a geometric series is one that has a common ratio. So to show that it is geometric, we really need to show that it has a common ratio. And the common ratio is equal to a term divided by its preceding term. So every time you have a term and you divide it with the preceding term, you are supposed to get the same value. So once that is the case, you have a geometric series. So all we need to do is to show that it has a common ratio. So a geometric series, we can say, has a common ratio R, which is equal, and I'm going to show that now there actually is a common ratio. So it will be -5 divided by 25, which also be equal to 1 divided by -5, which also be equal to -1/5 divided by 1, which also be equal to 1/25 divided by -1/5. -1/5. And all of them equal -1/5. All of them equals this, which then, if you want to write as a decimal, it will be -0.2. So all these ratios is the same thing. So by virtue of the series having a common ratio, it is geometric. And that's one way to show it. That's not the only way to show it. That's one way to show it. Another way to show it is to show that starting with the 25, the term that follows would be 25 times the -1/5. And the term that follows would be 25 times the -1/5 squared. That's what, so this would be equal to that, and this would be equal to that. And then you could continue. So that's one way to show it as well. But by showing that it has a common ratio, that is good enough. So I don't know what method the teacher would teach you. Maybe they teach you this way, or they teach you this way where you show the common ratio. Either way, you would get your marks. All right. So if we were to complete this one, it then would be 25 times -1/5 cubed, and then 25 times -1/5 to the 4th power, and so on. So that's another way to show that it is a geometric progression, because it is in the form a plus ar plus ar squared plus ar cubed, and so on. All right. Anyway, that's it. It says calculate the sum to infinity, giving the answer to 2 decimal places. So the sum to infinity of a geometric progression that is convergent, and remember, it is convergent when your common ratio is less than 1 but greater than -1. It becomes a convergent series, meaning it converges to a sum to infinity when the common ratio is a positive or negative fraction. And when we say fraction, we mean a value that is less than 1. We don't mean a value like 4/3, because 4/3 is 1 1/3. So we're not talking values like that, we'll say fraction. We are more talking a value like 3/4. That's going to give you a value that is less than 1, whether it's a positive 3/4 or a negative 3/4. If your common ratio is that, then it will converge. It will have a sum that converges to what we call a sum to infinity. And the formula for that is A/1 minus R. A/1 minus R. And for those who don't know how it comes to be this, The sum of a geometric series is a into 1 minus r to the n divided by 1 minus r. Now, if your r is a fraction, when your n becomes very large, it means that you're multiplying a fraction a large number of times. So for example, half raised to the power, say 50, is gonna approximate to 0. Higher that number of values, higher the number of values, higher the number of terms go, right? So the higher the value of n is, the smaller that fraction becomes, or that value becomes when you raise it to a power. Fraction raised to a large power is like you're reducing, like multiplying half 50 times. So it approximates to 0. And so what does that mean? Is that this term right here is approximating to 0. And if that becomes 0, you're left with a times 1 over 1 minus r, and that's how it comes to be that is a formula for the sum to infinity. I don't think they'll ask to prove it, but it's good to understand it. And it is actually on the formula sheet. This is on the formula sheet as a sum to infinity. So it's a matter of plugging in the a and the r in this. And so the a is the first term in the series, which is 25. So this becomes 25 divided by 1 minus, and the common ratio we said was this, or negative 1 over 5. So it's minus 1 over 5. This minus minus becomes a plus. So if we were to simplify this quickly by multiplying the numerator by 5 and the denominator by 5, then the numerator, 5 times 25 is 125 divided by 5 times 1 is 5. This minus minus becomes a plus, and the 5 here would cancel the 5 here, and so it becomes 5 plus 1 is 6. So it becomes 125 over 6. We want it to 2 decimal places, so we need to work this out with the calculator. Somebody work that out for me, please, and tell me what it is. 125 over 6.
20.8.
20.83.
20.83. So that is 20.83 to 2 decimal places, and that is it. All right, that is that. And I think that's the only series on this. Oh, there's another series right here. Aha, this is another series question. All right, so this is one where you basically use a real life. They want to give you a serious question in a real life situation. And we're doing this question, it's a matter of determining whether it's an AP or GP. That's one. Secondly, if it's a AP, you're really trying to find your A and your D and your number of terms. Then you want to find out if they're asking you for a term number or they're asking you for a sum to a number of terms. If it's a GP, then you want to find your A and your R and your number of terms. And the same thing, you want to find out if they're asking you for a term number or they're asking you for a sum to a number of terms. All right. So let's see what they're asking. So this question says a recent university graduate was offered a starting salary of $720,000 for the first year, with an increase of $5,000 at the start of every year thereafter. So this is looking like a AP, because you're adding this amount every year. So right off the bat, this is my starting value. That's my A. So my A, first year I have an AP. My A is 720,000. I'm going to work in thousands. I'm going to write 720. I know I'm working in thousands. So when I'm giving my answer, I will give it in thousands. And my common difference is 5,000. That's my D. I'm just going to write 5. I'm working in thousands. All right. I'm working in thousands. Okay. It says determine the number of years. So this question is asking me for an N value. It's asking me for an N. Determine the number of years. So it's asking me for an N. So N is the number of years in this question. Remember, every year is a term. Determine the number of years to the nearest whole number that it would take for the annual salary to be 20% greater than the salary of the first year. So it's basically asking me which year will the term become equal to 20% more. 20% more. No, 20% more is 120%. It's 120% of the starting sum of 720. Remember, we're working in thousands. That's what the question is asking me for, you know. When will the sum reach this? So if somebody can work out 120% of 720 for me, that's a term number we're trying to find. Huh? 1.2 times 720. That's what I want. Work this out for me.
864.
864. Good. So I want to know when my nth term is equal to that. Now the nth term of an AP is A plus n minus 1D. That's the nth term of an AP. A plus n minus 1D. And we're solving A plus n minus 1D equals 864. And we're trying to find the n. So right now we can make n the subject of this expression and then substitute the A, which is 720, the D is 5. So if we were to make n, and I would get 864 minus A, then I would divide by the D next over D, and then I would add this 1 and equal. I would add this 1 plus 1. That's gonna give me my expression. It's trying to use as little space as possible for this work. All right, so if I plug in the values, it will be 864 minus 720 divided by 5 plus 1. Somebody work this out for me now, please.
$29.8.
How much? 29.8?
Yeah.
Yes, sir.
29.8. So to the nearest whole number, that would be 30. I'm going to write 30 years. Because the question did say the number of years. All right, guys. Sorry about that. The technology again. Right. So I'm saying the question asks. Somebody back with me. Can you see the screen again?
Yes, sir.
Good. So the question asks us for the number of years. Number of years. Right? So I'm gonna say 30 years. That is the answer. Well, good at that.
Yes,
Are
sir.
okay? All right. That's
Yes, sir.
2022. Let's go to 2020. Good. Let's go to 2021. 2021. We're doing all the serious questions right down to 2012. More maths equals better maths. So 2021. We're doing all of them. Leaving out none. We don't know what's coming on the exam paper. Any question that repeat closely or in any distance way, we must get it. CXC must never repeat a question that you cannot do. That must never happen. All right, so this don't like to have any series. 2021. This is a series, you know, but it's more a logs question. So I'm not gonna do this one until it's all right. It's more logs question than a series question. So looks like there's none on this paper. Let me just make sure. Sometimes I come in question 1. This is question 1. And up to question 2, let's make sure. Don't want to skip over any. So they are trying to make that question a serious question. All right, so that is it. Let's look at 2020. Let's look at 2019. 2019. Working our way down. 2019. All right. So this is a serious question in 2019, right? You know this one. This is a serious question in 2019. All right. So let me erase this. All right. Let me make it smaller. Make everything smaller on this, so I don't actually erase anything. Let's make it smaller and put in there. Yeah. All right. So we're doing this question now. Let's put in blue with the contrast. So we're doing this question now. It says this is a geometric series, right? There's a geometric series. It says a first term and a common ratio. It says prove that this is a sum to infinity is equal to this. So I like question when they tell me to prove something. So you get your answer, you know you're correct. So in this geometric series, you need to identify your A and your R. Because the formula for the sum to infinity is simply A over 1 minus R. So if we can find the A and the R out of this, then we are good to go. It's quite easy. So from here, if you observe it, the A is the first term. So the A is equal to Y over X. And the R is the value that you multiply this by to get this. Simple as that, you know. So that now we're multiplying this Y by another Y to get the Y squared. So clearly, that's a Y on top there. I'm multiplying this X by X squared to get to this X cubed. So clearly, that's a X squared. So this becomes the R. So all I need to do now is drop this up here as my A and drop this down here as my R. And then I'm working towards proving that. It's a proof. So the first thing I'm gonna have is my Y over X on the numerator there. And then I'm gonna have 1 minus this on the denominator here, which is Y over X squared. And then I want to get rid of this X squared on the denominator, and I realize that this is a XY, and I want to produce the XY from this. So a quick way of getting rid of this fraction under here, as always, is to multiply the denominator by X and also multiply the numerator by X squared. All right, and it's gonna work itself out like magic. So S infinity comes when I multiply this by this, it cancels with the X there, and I end up with X times Y, which is XY. And so I'm halfway there. Divided by this times this 1 is a X squared. And then this times this cancels the X under X squared under here and leaves me with a negative Y. So this is actually guys. It's just that they brought it up and put on the negative 4 on it. So I'm going to bring this up and put negative 4 on it. And so S infinity equals XY X squared minus Y. But okay with that?
Yes, sir.
Yes, sir.
All right. Good. Think there's any other series on this paper. So we're doing them fast, you know, we're doing them fast. They are very easy. 2018 next. They are very easy. They're not lengthy question at all. They're testing very basic things. These are like the very basic of these topics. Here's another serious question right here on 2018. And they like to give geometry. This one says, in a geometric series, the third term is 25, and the sum of the first and the second term is 150. Now, once I say the sum of 2 terms, I can just list them. So the third term, now remember, the nth term of a GP is AR to the n minus 1. So for example, the 10th term of a GP is simply AR to the 9th power, AR to the 9th power, AR to the 9th power. The 15th term of a GP is simply AR to the 14th power. The 6th term of a GP is simply AR to the 5th power. So we'll keep it simple. So the third term is really AR squared. It is equal to 25. And then the sum of the first and the second term is 150. So since it's only two terms there, I'm not going to put any formula for that. It is simply A plus A times R. This is the first term. This is the second term. It's equal to 150. What we have now is a pair of simultaneous equations that are derived from a geometric series. Now listen now. A little tip for you. When you get simultaneous equations that are derived from a geometric progression, you tend to solve them by dividing them. You divide them to solve them because they are created by multiplying. So, because they are created through the process of multiplying by a common ratio, when you're solving them, you tend to divide. You divide them. When you're solving simultaneous equations that are generated from an arithmetic progression, you tend to subtract the equation to solve them. You subtract the equations to solve them. So GP equations, you solve them by dividing. AP equations, you solve them by subtracting. And sometimes you add the AP equations. So these two equations, I'm going to solve them by dividing. So I'm just going to divide one over the next. So I'm going to divide, for example, this one by this one. Simple as that. So if I were to call this equation 1, call this equation 2, they were derived from a GP. I know that when I'm solving GP simultaneous equations, the easy way to do them is to divide them. I'm going to do equation 2 divided by equation 1. And it's quite simple. You take this side and you divide this side. So it's A plus AR divided by AR squared equals, then it is this side divided by this side. So it's 150 divided by 25. And so now I'm solving that. But because I have A in all terms in the numerator and I also have A in the denominator, it means that I can divide through by A. I can divide the numerator by A and divide the denominator by A because I have A in all terms on the numerator and A in the term on the denominator. And so I can divide up here by A and divide under here by A. All right? Simple as that. So when I divide the numerator by A, I'm dividing numerator and denominator by A. Dividing by A. Numerator and denominator, I'm dividing by A. Divide this by A, it becomes 1. Divide this by A, it becomes plus R. Divide this by A now, it becomes R squared. Another way to look at this, guys, is that you factorize the A. So let's look at it another way. If I were to factorize the A out of the numerator, it becomes A into 1 plus R divided by A times R squared. So the A cancels the A. And left with 1 plus R over R squared. That's another way to look at it. All right? Many ways to skin the same cat. And then now this is equal to 150 divided by 25. That's 6. 6 times. 4 in 100 and 2 in 50. That's 6 times. And then we have a quadratic right here. We're going to multiply this R squared over here. And it becomes 1 plus R equals 6R squared. That's a quadratic equation. We just need to transpose these two over here and make set it out in a standard form, right? So it becomes 6R squared minus R minus 1 equals 0. And so this factorized easily into 3R, 2R, 1 and 1. Signs are different, give the greater product the negative sign. Far product is 3R, the near product is 2R. The larger one must be negative, so I need to put the negative here and the positive there equals 0. They did give us some condition on the R. They said the R must be greater than 0. And they want us to determine the sum of the first 4 terms. That's what they want, right? So we're doing it by finding R first. So this is going to give me R equals a third, negative third. This is going to give me R equals half. This one is not valid because R must be greater than 0. And so the R is equal to half. Now, they want the sum of the first four terms. We basically have the sum of the first three terms already, you know, right here now. Because this is the sum of the first two. And this is the third one. So all we really need is a fourth term. And the fourth term is obtained by multiplying the common ratio, multiply the common ratio with the third term. So multiply the third term with the common ratio, we have the fourth term. So some of the first four, we don't need to use a formula this time, right? Some of the first four terms, let's do it right here. Let's put it right here. Right? So the first four terms will be A plus AR squared plus AR cubed. I don't have to use a formula. These two was 150. That's what we have, right? 150 plus, this was the third one, which is 25. And then to get the fourth one, you basically multiply the 25 by the common ratio. So this fourth one is 25 times half. And if you add up all of that, you get the answer. But understand that? If you wanted, you could, use the formula as well. But because it's just four terms, we can just add them up individually, and we already have three of them. So work that out for me, please. That's 175 plus, that will be half of 25 is how much? 12.5. So it's 185.5, 187.5. That's all? 187.5. That's correct? Somebody check that for me.
Yes, sir.
187.5 is the answer, and that's it. If you want, you could use a sum which says it is A into 1 minus R to the fourth power over 1 minus R. We do that as well. That will give you the same answer because the A, did we calculate the A? See, we didn't calculate the A. So this is the easier way to do it. Okay, you don't have to calculate the A when you do it that way. You get me? You don't have to calculate the A when you do it that way. To do it this way, you have to calculate the A. And we did not calculate the A. We only calculated the R. So you don't need it. So we're not going to do it the hard way. We're going to keep it the easy way. All right? We're not going to do the mathematics any way that is hard. Keep it easy. All right. So we didn't do this question. We didn't do this question. No? We didn't do this question, which is a quadratic. So let's do it now. Let's do it now. We didn't do it. It's a alpha beta question. Let's do it. Let's skip this one. So it gives us this question, this equation, and they want us to find this now. So this one is a little bit nicer than the one that we have done so far. So to do this, we know we're going to need the sum and the product of the roots. We're going to need them. So let's write them out from, which is alpha plus beta is minus b over a. So it's minus -5 over a, which is 2. That becomes 2.5. It becomes positive 5 over 2, which is 2.5. We could put 5 over 2, you know, we can write 2.5. And then alpha beta is c over a. That's 3 over 2. I'm going to put 1.5. You could put 3 over 2, but it's okay to put 1.5. I don't need to work out this value. So we can say now, the 1 over alpha squared plus 1 over beta squared. The first thing again is that I want to make it a one fraction. So I'm going to do the classic thing of multiplying this one by beta squared over beta squared. I multiply this one by alpha squared over alpha squared. And so the two denominators become the same. So the numerator becomes alpha squared plus beta squared. Alpha squared plus beta squared over the denominator becomes alpha beta squared. Alpha squared beta squared. Alpha squared beta squared. All right, we're working towards getting these expressions out of those, right? Out of that. So this alpha squared plus beta squared is the same as alpha plus beta r squared minus 2 alpha beta, like stuff that you just must know. So on the must know sheet that I showed you earlier, just must know these things. You have to waste time thinking about these things when you just know them, because they are pretty standard things that they set. So it makes sense to just know them. Divided by this now is a perfect square of alpha beta. And so I've written the expression in terms of the sum of the roots and the product of the roots. I know it's just a matter of dropping in the values. So the sum is 2.5 right here. So it becomes 2.5 squared minus, the product is 1.5. So we're subtracting 2 times 1.5. And we're dividing that by 1.5 squared. 1.5 squared. Put that in the calculator for me, please, and tell me what the answer is. So we're doing this one, we're doing quadrant. How much? 13 over 9? That's 13 over 9. And that is the answer. Should I put it in right? Okay. 13 over 9, and that's the answer. All right, that's that. So we'll skip that question in the first part, but catch it. Very good. We don't want to leave any stones unturned in this thing. We don't know what's coming on the exam paper. All right, that's 2018. Let's go to 2017 now. 2017. 2017. We're going to finish with series tonight. Start with a different topic tomorrow. We have 4 days. 2017. So looking for series now. Series. All right, so a series question. This question is very interesting. I remember this question. All right. Remember this question. This question is not a fair question. I'm going to tell you why it's not a fair question. It's not a fair question because these digits are too large, too many places. And so for you to ensure the accuracy of this question, and this was a geometric progression question, see? A geometric series. Now for it to be accurate, when you calculate your R, you have to use a large number of decimal places because you're multiplying by a large number. So because this number has 1, 2, 3, 4, 5, 6, 7 digits, you maybe want to make your R go to 7 decimal places. Remember, to go from term to term, you're multiplying the values by your R. So if you correct your R to a small number of decimal places, then the accuracy of the numbers will be lost. All right. So for this question to be accurate, you have to work with a large number of decimal places because you're working with a very large number. So bear that in mind, guys. All right. If you get one like it again, you have to use a large number of decimal places because you're multiplying your R with a very large number. That's 54,000. All right. Question says, an accountant is offered a 5-year contract, with an annual increase, The accountant's salary, the accountant earned a salary of this amount and this amount in the 3rd and the 5th year. So it means that this is the 3rd term and the 5th term. So this is the 3rd term and that is the 5th term. It says respectively, if the increase follows a geometric series, calculate the amount paid in the 1st term. In other words, I want to find E. So what this question means, if we're going to make it a GP with a 1st term of A and a common ratio of R, it means that this is your 3rd term, it is AR squared. Let's write it. It means that AR squared, the 3rd term is AR squared, which is equal to this amount. 53,982.8. I'm going to leave out the dollar sign. I don't need it. I know that I'm working in dollars. And this is the 5th term, which is AR to the 4th power. So AR to the 4th power is 60598.89. If I want to put the 0 on the end of this one, no problem. So these are two simultaneous equations again, obtained from GP equations, and so you solve them by dividing. You divide them. So this is equation 1, that's equation 2. I'm going to divide them. I'm going to do the 2 divided by 1, and then this divided by that to get my common ratio. Right? Because I'm going to cancel the R when I divide. All right, so I'm going to divide 2 by 1. When I divide 2 by 1, I'm going to get AR to the 4th power over AR squared. Or simply, you could just write R squared for this. That's what it becomes. It becomes equal to this thing over this thing. So So it becomes 60598.89 over 53,982.80. And this is really R squared. So let me shift this over and just write R squared in front of it. So I don't have to use up too much space. This works out to be R squared, which is now equal to this. So work out what R squared for me, please. Work out this for me. And then R is going to be the square root of that. So work out what R is for me. And then after we find the R squared, we can drop that R squared value back right here and divide and get the A. So tell me now what you get for the R squared. Somebody write this word for me. Tell me what you get. And give me a large number of the. Yes.
1.1.122 55 9223.
All right, so this has 1, 2, 3, 4, 5, 6, 7 digits. You can work with 7 decimal places. 1, 2, 3, 4, 5, 6, 7. All right, there's only 2 more decimal places. So that is our R. All right, that's our R squared. And then now I'm going to square root this now to get my R. So tell me my R under here. Therefore, R equals square root this now and tell me what R is. And give me about 7 decimal places again. Yeah, because this is 7 digits.
1.059.
Yeah.
5089.
All right. And when you're finished, guys, if you want to work with 1.06 and try the question, for example, if you use 3 significant figures as we normally do, you're going to find that the accuracy of this question is going to be lost. All right? It's going to be lost. All right. So this is our R and this is our R squared. So to find the A right now is kind of easy, right? Because this is R squared. So we can use this same value for the R squared in this equation to get the A. And that's what they asked us for first, right? So if we drop the R squared on this, we can simply write that our A becomes equal to, from this, our A is going to be 53982.80 divided by R squared, divided under the R squared. So we can place this as our R squared under here. And you work it out for me. That's 1.122559223. Tell me what the A comes out to be. And it's the amount in the first year, so I'll put the dollar sign on it now to answer the question. Tell me what it is. That's what I don't like about this question. You have to use too many digits to ensure the accuracy, because the numbers are just too large. That's what I don't like. The process, what we do is the same, but just don't like the values are not friendly. Where the sort from me, please? Tell me what I get.
48,089.
48,000 what?
089.
089. That's it.
Point.
No decimal place. Point.
0.04.
04. All right, that's the amount in the first year. All right, that's that. Then they say total salary at the end of a contract. What is this asking us for? It's asking for the sum of the payments. And what was the length of the contract? The length of the contract, they told us, was 5 years. So we're doing the sum to 5 years now. So we're doing the sum to 5 years. Now remember, the sum of a GP is A into, since the R is greater than 1, we're going to write R to the N minus 1 over R minus 1. That's the formula we're using. All right, so plugging in the values here, and we're going to use those big, long digits. So the sum to 5 years equals, the A is this value. But our choice, so let's have to write it out. 089.04. That's why I don't like this question. The digits are too much, too long. Then it's 1 point, the R that we have, 1.059508 raised to the power 5 minus 1 divided by 1 r minus 1, right? R minus 1, which is again is this value minus 1. 1.059508 minus 1. Put that in the calculator and tell me the sum of the 5 years. And you have to put the dollar sign on it again. It's also the total salary, so you put the dollar sign on it. Very so from it. The question not difficult, you know, just the digits not friendly. That's all. Now, that's a difficult question. Just that the values are not friendly. Not friendly. That is all. Then what I get, please. Let's type it in the calculator exactly as it appears here. Make sure you have one of those calculators, textbook display calculators. Then what I get. Anybody? Take it long. That's the only way to be accurate. Zero, 8, 9 to the 54 minus 1. And then you can just write this on here, so by subtracting 1. 0.1059 95089. There you get. Get an error? We could work and put in exam.
Yeah, I got 207,000.
What do you get? How much you get?
270,816.
270,816. Point what?
74.
0.74. All right. That's it. I mean, answer not so important. The process is more important right now. All right. But that is it. But because of the large numbers, it's very important that you use a large number of decimal places. Smaller number of decimal places you put against large numbers, this is the more the accuracy goes down. You lose the accuracy in the answer. But I think CXC, if you use 1.06, they'll give you, they'll work with what you get. But just as I know the accuracy is reduced, we use a small number of decimal places on a large number. All right? That's just how it is. All right, let's go to 2016. 2016. 2016 is right. Where is it? 2016 is right here. All right, so this is a serious question now. This summation and series, there's a summation. So first thing, I wanted to work this out. This is a sum to 25 terms, right? This means sum of. The first thing, I don't work with negative powers if I don't have to. So I'm going to recognize this as the sum. This will be a different color. Recognize this as the sum from 1 to 25 of 1/3 to the power n. And then to see what kind of series it is, you write out the first few terms. So this will be equal to, first term is when n is 1, so that will be a third, plus when n is 2, you get 1/3 squared, plus when n is 3, you get 1/3 cubed, plus, and you go all the way down until you get the last term, which is 1/3 to the 25. But this tells you that it is really 25 terms, because it's really from n equals 1 to n equals 25. So this is a sum of 25 terms. This becomes a GP, obviously, with a first term of a third and a common ratio of a third. And the number of terms is 25. And that's what you're doing the sum of. It's quite easy. Using the sum formula, sum of a GP, 25 terms, becomes A into 1 minus r to the n over 1 minus r. I usually use 1 minus r when the r is a fraction less than 1. All right, that's it. I'm dropping in these values on this formula up here to get the sum. So the sum, 25 terms, becomes A, which is a third, bracket, 1 minus, A again is a third, raised to the power 25, divided by 1 minus a third. Drop this in the calculator and see what you get. Come, Kai, come drop this in the calculator. Yeah, this one. So there's a third right here, bracket, 1 minus a third to the 25th power, divided by 1 minus a third. Work it out for me.
I got a half.
Good. 0.5 or half. Beautiful. 0.5 is the answer. All right, lovely. All right, this one now. This one says, a man invested X dollars in a company in January 2010, on which he earns quarterly dividends, right? At the end of the second, third, and fourth quarter in 2011. Now that's in the next year, you know. Remember, you've already gone through 4 quarters in 2010, you know, because there are 4 quarters in a year, right? So the second quarter in 2011 is really the 6th term, you know. That's the 6th term, you know. And the third quarter in the second year is the 7th term, and the fourth quarter is actually the 8th term, you know. So these are the 6th, 7th, and the 8th term that they're giving us right here. We're mindful of that. All right. And based on these consecutive values, it is clear that the common difference is $15 by observation. No calculation needed for that. It says, calculate the total dividend. This is a sum. It means that they're asking us for a sum on his investment at the end of 2016. At the end of 2016. So what we're going to need to know is how many quarters are there from 2010 to 2016. Now, let me tell you something now off the bat, and don't forget it. When you're doing questions with the years, we tend to want to count the number of terms by subtracting. So might, for example, want to say the number of years included here, and the number of years involved here is calculated by doing 2016 minus 2010. And we're going to get 6, which is wrong. Because the number of years included in this question is actually 7, because you have to include the 2010. If you list them out, it will be 2010, 11, 2012, 2013, 2014, 2015, 2016. 1, 2, 3, 4, 5, 6, 7. So that's 7 years. And each year had 4 quarters. But plenty of people don't subtract them, you know, and then say 6 years, you know. No, when you're dealing with question in years and you subtract, you have to remember to add back the first year, because the first year is included. All right. So the number of years between 2010 and 2016 inclusive is 7 years. And each year had 7 quarters. So the number of terms talking about is 28. 7 years, let me write it out. 7 times 4. 7 years times 4 quarters, that's 28 payments. There's 28 terms. So the only thing missing right now is the A. What is the first term, A? We can find that because they gave us this value, for example. That's the 6th term. That's the second quarter in the second year. That's a 6th term. 4 quarters in this plus 2 quarters, that makes 6 quarters. That is the 6th term. So the 6th term is 100. We know that we're working in dollars. So I'm just going to write 100. 6th term is 100. The 6th term is A plus 5B. We know that these 15 going to drop the 15 here. And so we're getting A plus 5 times 15 equals 100. Now this is 75, don't it? And so subtract the 25, you get the A equals 25. 75, you get the A equals 25. All right? So we find the sum of 28 terms, guys, of our AP. The sum of our AP, that's right here in red. Sum of our AP is n over 2 into 2a plus n minus 1d. That's a formula that's on the formula sheet. Another formula that is useful is n over 2 into a plus l. That's when you know the first term and the last term. Note, this is 2a plus minus 1d. This is a plus l. Why are they the same? Because the l is a plus n minus 1d. And so you have 2a and the n minus 1d. That is the result there. Right? So it's the same formula really. It was a useful formula when you know the first term and the last term. This one. It's not on a formula sheet. This one is not on a formula sheet. So basically we're going to be using this for the sum, this one. We're going to be using this one up here to find the sum. So let's just drop it down here and do the calculation right here. So the sum to 28 terms, the sum to 28 terms becomes 28 over 2 into 2 times a, the a is 25. So it's 2 times 25 plus n minus 1. 28 minus 1 is 27 and the d is 15. Put that in the calculator and put the dollar sign in front of it because it's money, right? Money. So working with money. So put the dollar sign in front of it when you get the answer. Sum to 28 terms, and that will be the answer. Where that go? $6,307. All right, beautiful. All right, so that was at AP. So you're looking for the A, you're looking for the D, you're looking for the N, and drop them in the formula. All right, simple as that. All right, 2015. What time is it now? All right, so we're gonna just finish the AP and GP and call it a night. All right. So we're gonna on week 2012, we'll just call it a night and we'll start back tomorrow. 2015 is right here. Let's look at it. 2015, oh, we're gonna need it. The other stuff now. So it will be in one of these. This is our GPA. This question right here. This question right here. This one is a serious question. Let's see, you can work it down here. It says an employee at a company is offered an annual salary of $36,000, which increases by $2,400 per annum per year. So similar question. Determine the annual salary the employee should receive in the 9th year. Easy question. In this question, the A is 36,000 and the D is 2,400. So AP can increasing by the same amount each year, you're adding the same amount each year. And it's asking for the salary in the 9th year, not asking for a sum, it's asking for the 9th term. Right? So the 9th salary. So it's asking us for the 9th term. That's what it's asking us for, which is A plus 8D. Can that make sense? Because you start with this and you add this 8 times. As you're talking about the 9th year. So it becomes 36,000 plus 8 times 2,400. Can I put the dog in the room, man? What is all for me?
5,000.
I put the dollar sign in front of it. 55, 200. All right, guys, hold on. I'm see if I can just check the dog a bit. Hold on a second. All right, guys. Sorry about that. Jesus. Hold on 1 second. Quick. 1 second. Is you want to? All right, guys. Sorry about that. All right, 2014. 2014. Let's do this. 2014. All right, so again, we're looking for the serious question. Mute your mic, please. Mute your mic, please. All right, so this one is right here. That's a series. This one. All right, so this one says, this is a series. Show that it is geometric. Same thing again. Show that it has a common ratio. All right, so if it is geometric, it has a common ratio. That's what they're gonna say. I'm gonna show that that common ratio R is equal to this divided by that, which is 0.02 divided by 0.2, also equal to this divided by that, a term divided by the preceding term, 0.002 divided by 0.02 is also equal to this divided by this, 0.0002 divided by 0.002. That works out to be 1/10. If you work it out, it's 1/10. You keep multiplying by 1/10 to go from term to term. So that is 1/10, right? Or 0.1. So because of that common ratio, it is geometric, right? And then I want the sum to infinity, giving the answer as an exact fraction, right? So the sum to infinity is a over 1 minus r. The a is 0.2 divided by 1 minus the r is 1/10. You want the exact fraction. So to simplify this quickly, I'm going to multiply up here by 10 and multiply under here by 10. And when I multiply the numerator by 10, I'm going to get 2 over, when I multiply the denominator by 10, it's going to be 10 minus, it's going to become 1. 10 minus 1 is 9, and that's the answer as an exact fraction over 9, an exact fraction over 9. But okay with that?
Yes, sir.
Yes, sir.
Yes, sir.
3 more papers to go. 2013, no, 2 more, 2013 and 2012. And then we're done for the night. Right. Sorry about the dog, Reese. Doing a lot of headache around here. 2013. We have to do this. We have to do this. Revision is important. More maths, it was better maths every time. This one now is a series. This one is a series. It says find the sum to infinity of this series. And it says note, this series can be written as the sum of 2 geometric series. So there are 2 series in there. If you look at it, one of the series will be with these values. Look at it. And the other one will be with these values. So I have to break it out into 2 series and calculate the sum to infinity of each of them. So we need to find the A and the R for each of them. So let me bring up the other side of the screen and do it over here. Let's do it over here. All right, so it's like we have series 1. Let's call that series 1. And series 1 will be GP1. GP1 will be a quarter plus 1/4 cubed and so on, right? And GP1, the A is a quarter, obviously, and the R would be to go from this to this, you multiply by 1/4 squared. This is a cube. So to go from this to this, you have to multiply by 1/4 squared. So the A is 1/4 squared. And so the sum of this first part, sum of, let's call it sum to infinity 1, is A over 1 minus R. Let's write it down here. The sum to infinity is always A over 1 minus R. So on this series, the A is a quarter. So I'm going to put a quarter over 1 minus the R is 1 over 4 squared. That's it. And then to simplify this quickly again, we can multiply up here by a 4 squared and multiply under here by a 4 squared. I can just drop it in the calculator. We multiply this by this, we're going to get 4. We're going to get 4 over, we multiply this by this, we're going to get 16 minus 1, which is 15. This becomes 15 over 15. We're going to go for GP2. Let's do GP2 now. So second GP based on it will be the ones in red. All right. So it's going to be 2 over 4 squared and then 2 over 4 to the 4th power. That's GP2. In GP2 now, the A is this, 2 over 4 squared. And the R, how do we go from this to this? Again, we multiply by 1 over 4 squared because the 2 comes back. But this 4 squared becomes 4 to the 4th power. So basically multiplying by 1 over 4 squared. And so this sum to infinity of GP2, this is our A, which is 2 over 4 squared over 1 minus, this is our R, 1 over 4 squared. Simplify it again by reducing this, by eliminating that, multiply under here by a 4 squared and multiply up here by a 4 squared. And that becomes, this cancels this, give me a 2 on the numerator here over the 4 squared is 16 times 1 is 16 and it cancels the 4 squared out of that, give me 1. So 16 minus 1 again is 15. And so now the sum of the two of them is to add these two, which gives me 6 over 15. So see here now, the sum to infinity 1 plus the sum infinity 2 becomes this plus this, which is 6 over 15. And if we reduce that by dividing 2 by 3, it becomes 2/5. 2/5, and that's his answer. We divide numerator and denominator by 3 to get 2/5. What do you go to that? One last question.
Yes, sir.
All right. Good. One last question, which is the 2012. And then we're going to call it a night. What topic would have completed? Would have completed 3 topics. All right? 3 topics. So I'm going to ramp it up again tomorrow. Ramp it up tomorrow, 2012. All right? 2012. We're looking for 2012. Where is it? 2012. 2012. Ross. 2012. All right, 2012, looking for the series question. Series. This is a series question in 2012 right here. This one. Right here is our series question in 2012. All right, tomorrow we're going to do inequalities and so on, right? We're going to do trigonometry, coordinate geometry, vectors, series, logs, indices, differentiation, integration, kinematics, statistics, probably. We're doing all the topics. We have 3 more days, right? 3 more days. So maybe one of the days we have to try and do maybe 4 topics on one of the days. Today with the 3, we might need 4 topics tomorrow. Let us circle. At least will be in the day, so we can get more done. All right. Let's see. This one says a customer repays a loan monthly by increasing the payment each month by X. So this is an AP, increasing it by the same amount each month. So this is like a D. All right. It says if the customer paid $50 in the 5th month, that's the 5th payment, you know. So the question is kind of telling us that the 5th payment is $50, right? The 5th payment is $50. The 5th term is $50. So I'm going to write the 5th term as A plus 4D. It is equal to $50. And $70 in the 9th month. The 9th month, this 9th month is A plus 8D. And this 5th month payment is A plus 4D. The 5th term and the 9th term. So I can write that A plus 8D equals $70. calculate the total amount paid at the end of 24 months. Right? So they put that part in blue. Total amount paid in 24 months. So 24 months is telling me that the N equals 24. And total means that I want the sum. If I wanted the payment in the 24th month, that would be the 24th term. But I want the total amount paid at the end of 24 months. So that is telling me that I want the sum 24 terms. I have to read the question carefully. If the question had said, what is the payment in the 24th month? That would be the 24th term, which would be A plus 23D. But this question is asking for a sum. So to find this sum, I already know my N is 24. I need the A and the D. I have to solve these two equations simultaneously. Same thing again. They were derived from AP, from an AP. So you solve them by subtracting. I just need to subtract them to solve them. All right? Obviously, we'll subtract these. 1 and 2. I'm going to do equation 2 minus equation 1. So I'm doing this side minus this side. So first the A, wipe out the A. And 8D minus 4D is 4D on the left side. Equals. Right side is 70 minus 50. 70 minus 50 is 20. So therefore the D equals 5. If we divide by 4, the D equals 5. Then if I take this 5 for the D and drop it up here in the equation, 5 4 is 20, and I have to add 5 4 is 20, I have to add 30 to 20 to make 50. So the A equals 30. So A equals 30. Let's check it. If I drop this right here, the 5 40, 40 and 30 is 70. Good. So the A equals 30. All right. So the A, the first payment is $30. Then I need to find the sum to 24 terms. The sum to 24 terms is N over 2, which is 24 over 2, into 2A. That's 2 times 30 plus N minus 1. Let's shift this over a bit. N minus 1. N minus 1. N minus 1. So it's 24 minus 1 is 23 times D. The D is 5. And once I put that in the calculator, I will get my answer. Can somebody work that one for me, please?
$2,100.
Put the dollar sign in front of it. Thank you. 2,100. And that is that. All right, guys. So we're going to stop it now tonight. It's past the time. Just about the time. Right. Good going. Good timing. Just about the time that we said we'll finish. All right. And then tomorrow we start back. Hope you can join us. Tomorrow we want to revise all the topics. We want to do all the questions from 2012 right up to 2022 and include the specimen paper. We're taking it topic by topic. All right. And we work our way right up the line. There are some topics we're going to skip out on some of the past papers, like the functions. Our functions no longer on the syllabus. And some of the kinematics, because the kinematics that they're setting now is different from the kinematics in the past. So if we might do the kinematics as a last topic, so that we, if necessary, we'll skip out the ones that are different from the type that they're setting now. So I think we might leave the kinematics for last. All right. The statistics, we have to do all the statistics because the standard of the statistics does not change. It is the same as before. But the kinematics, they're reduced in what's the word? They reduce the level of difficulty of the kinematics. All right, let's put it that way for now. All right, guys. So see you all tomorrow. I'll set up the Zoom and share the link and all of that tomorrow, and hopefully we'll have a good session tomorrow. Okay, guys. Good night.
Good night, sir. Enjoy your night.
Right,
All right. Bye-bye.